said, say something.
Something.
Huh? Check.
Check. Hi, Ballant. Can you hear me? How's the level?
Hey. Hey, can you hear? Okay. You can see, but they don't have audio.
Test.
Yeah, you're good.
So it looks correct.
Yeah.
Test. And that's red line. If I lean in, it pegs.
Yeah. Yeah. I can hear you. You're good.
Okay, so it must be on their end.
On their side, yeah.
Okay.
We're just getting set up. You're all good. All right, so we'll get started in just a second. Winston-Salem's kind of getting situated. They're in a new place today. So, how's everybody feeling so far about SQL? Good. Good.
Were there any parts yesterday that after a night's sleep have disappeared? Any nice questions on?
We'll find out.
Yeah.
We're gonna find out. Find out the hard way. I know sometimes that happens to me. Like I'll get 20 pieces of data, and the next day, like 3 have disappeared. So there's definitely a lot to learn. So
As long as they've disappeared into long-term memory, that's okay.
that's true. As long as you can recall them later at that moment you need them.
Yeah.
You let me know when you want me to start officially. Okay. All good?
You're still working on it, but go ahead.
We're going to go ahead and get started. That's
Yep.
cool. That'll work out because I'm going to start today with a little bit of review and do a couple things that we actually did yesterday again because of their importance, and just to sort of get our brains warmed up for another day of talking about this stuff. So I'm still in the original database we left off in yesterday. I called mine Echo. It was our 5th database. Remember, we have customers, we have phone numbers, and we have favorites, and we have to-do items. Those are all in my current Echo database. So I want to revisit the concept of one-to-many. And the reason I want to revisit it is it's the most popular relationship, and we're talking about relational databases. Once it goes from learning it to really setting in your mind, it finally clicks, which it might not happen yet. It might not have happened yesterday. It could take a while. Once you get that relationship, the many-to-many, which is the other big one, is nothing more than 2 of those. So if I can focus on one-to-many a little bit longer, I think it might be able to help you out. So we're going to revisit the same database here, and you can just follow along if you wish. Or you can watch just for this beginning part. Let's look at the state of the database. Let's look at what data we have, because I want to make sure we all know where we are. I did change this table. It has 1 new record. Its schema is the same, but this is our customer table as of my latest database. Remember, we had Bob and Alice from yesterday. That was already there. I added Charlie today because I need to show an example and I needed a specific data setup. And for now, I'm going to go back to phone numbers. We left off yesterday with favorites. I will come back to that, but I want to start just with the one-to-minis. So just to review, you can see the database. I've selected from both tables just so we all know what's happening. We got 3 customers, Bob, Alice, and Charlie. Bob has 3 phone numbers, Alice has 1, and Charlie has 0. Okay? I would, if you are following along, try to get your data set up in this way so the examples I'm about to show will make sense. Once again, Bob has 3, Alice has 1, and Charlie has no phone numbers, which is totally fine. In our product, in a one-to-many relationship, you're allowed to have no children. That's perfectly fine. This is normal in a database. So I'm going to open a new query window, and let's say all we really want to see is what are all the phone numbers. We've already seen that query. I will retype it. I'm going to use that as my starting point. And this is a tactic I actually use as a developer. I don't always type the query as its final version the first try. I sort of just start with a simple version that's currently not exactly what I want just yet. Then what I can do is I can say, well, remember, this is a one-to-many. I'm only looking at the child data. So although I have all the phone numbers on the screen, and I technically have the customer IDs, I don't know the customer names. And remember, what do? We need to pull from more than one table. What is that? A join. That's right. So let's bring customers into the fray. We use our join predicate is always going to be the same as the relationship. Like I said, in other products, as you venture out in the real world, some of these do start to get more complicated, but the vast majority of the joins that occur in a well-designed database, keywords, are usually going to be this straightforward. So there we go. We still have the same 4 records. They're all joined together now. There's some duplication of records. Remember that the customer ID is in both the customer table, that one, and the phone number table, so that's duplicated. But for the sake of just pressing F5 and seeing our data, this looks fine. We've got 4 phone numbers total in the database, and we have 4 rows in here. But I'll ask you the question, is this all the data in these tables? No. What's missing? Charlie. Charlie is not in the data, which is okay if all you needed was phone numbers. But what if you needed to ask the question, who is everybody and all their phone numbers? What if you needed a full, complete list of all customers and all phone numbers, but also joined? Well, there's a special case for that. And as Ali pointed out yesterday, there's a few ways to join. There's not a lot. The most common one is what's already on the screen, the inner join. This is the intersection on the Venn diagram where you have just the middle part colored in. But sometimes we want, as I said, all the data at least on the screen. So how do we do that? There's this concept, and I'm actually typed this backwards from what I should have typed it, but I'm going to call it a right join. And I'm just going to press F5, and let you look at the data. Right, let that click for you a moment. What's happened? Well, the data that was missing came back, right? Charlie is on there. So what did I mean when I said write join? Well, first I'm going to visualize this. Now, I've typed this query in a way that is most commonly appreciated by developers, and that is the select occurs on this line, the from occurs on this one, and the join occurs right here. Some people will even put the on clause on the new line or indented. Just be ready for that. Remember, the white space doesn't matter as far as the computer is concerned. That's all for human eyes. Computers don't care about that stuff. But I'm going to change this a little bit by just taking out the white space, because I want you to look at it like this. Whenever we use a direction, because there are left joins as well, what that noun means, left or right, means which table we want everything from. Okay? And I want you to visualize it exactly as I have on the screen. The phone number, the from, is on the left side of the query window, and the customer is to the right of it. So when we say write join, we mean we want all customers, and by the way, join them to phone number whenever possible and bring in all the phone numbers. That's basically what that means. So you end up with the data set that we see. We absolutely have all customers. We will have customers duplicated every time that they have duplicate phone numbers. Remember, Bob has 3 of them, so he appears 3 times in this record set. That's okay. We wanted that. Alice only has 1, so she appears once and has her 1 phone number. The key here with a left join or a right join, both which function the same way, just depends on which side of this layout the tables are on. Since we said right join, we definitely want all customers. Charlie's on there, but he has no phone numbers. So the database gives us null across the board for what would have been his phone number. Remember, these are all the columns that I've highlighted here that come from the phone number table. So, and this is common. This is inner joins are the most common join, but left and right joins, both of which are the same mechanism, just which direction we're talking about, are probably the second most common, and it's for this very reason. Harper?
We've got a request just in OBS. Can you mute your cam real quick? Can you switch over to that? Because it's blocking like what's in the upper right-hand corner. Like just in OBS. Can you pop that open real quick?
They don't want that permanently though.
Just for now, because it's blocking it's blocking the query.
Yeah, about that?
Yeah, there you go. Put it in different.
Now they can still see me.
Perfect. Thank you.
So I'll reiterate what they missed, just to make sure. The visualization, by taking out that white space and making this all in one line, this right means customer. It means that's the one I want all of them from. Left and right joins are identical, it's just directional how you type the query. They don't fundamentally act any different. In this case, because I typed phone number as the from and customer on the right side of it, and I wanted to make sure I had all customers, a right join was the way to go. So I wanted to point that out. So remember, when you do the inner join, you only get intersections, and so it leaves out data on both sides that can't be joined. But you can use right and left joins to bring in all the data from another table. There's another join that I'm not going to cover just yet. We'll cover later on. But I wanted to start off with the right and left. Any questions about left or right joins? You go ahead.
Can you just explain one more time? So like, wasn't the customer table and the phone table already juxtaposed? So like, what did the right join really like just do?
Well, let's take it out. That's the cool thing about SQL. When I go to show you C#, it takes a little bit more time to experiment. But T-SQL with SSMS, you can experiment so quickly. I'm just going to take it out and press F5. And the key thing you'll notice is Charlie disappeared. So this is an inner join. So I'll fully type it just to have it shown there. It's an inner join, so we only get records that are in both. So because Bob has greater than 0 phone numbers, he's in this record set. And in fact, he's actually duplicated a total of 3 times. 1, 2, and 3. Alice has greater than 0, so an intersection successfully occurs, and she's on there with her 1 phone number. But Charlie's missing, because although Charlie exists in the universe, he has no phone numbers. And this is only, the inner joins only match when there's at least one match, at least one record match. So if that's what your application needs right now, just show me all the existing phone numbers and the customers, this is the correct query. But there will be times when the application needs a full list of customers and their phone numbers, but if they have none, please still give me the customer at least once on the screen. And that's where I typed in right join. Right meaning, there we go. Right meaning I want all the things on the right side, which is customer. That's why I laid this out visually, so phone numbers are on the left side of the screen. When I press F5 now, this data set's the same, it just adds one row, and it adds Charlie without a phone number. That way I get at least the customer at least once on the screen. If you think of it from an application point of view, that you could probably make up a scenario where that would make sense, just if you get kind of creative about it. Maybe this is a query that's for an admin user for the website, so somebody who owns the website who's reselling its services. The admin might want some sort of summary report. Show me all the phone numbers, and by the way, don't leave out any customers. If that's what your client needs in their software, this is how you write the query. Neither one is right or wrong. It's whatever your needs are, and that need is going to vary from query to query for the rest of your career. So you're going to change it every time to whatever you need. Was that helpful?
Thank you.
All right, great. Any other questions, left and right joins? I will be typing more today. You will see more. So I know it's hard to fully understand a concept when you see only one concretion, one example, but I will type more. Not with this example, but upcoming soon. So I'm going to stay on these same pair of tables. I'm not yet going to go to the mini-minis just yet. If you remember from yesterday, I also talked about a concept, group by. I want to review that a little bit using these same two tables. So remember, we still have 3 customers and 4 phone numbers. So let me just start with the phone numbers again, nice and simple. There are our 4 phone numbers. Now if you remember, I'm going to go back to yesterday morning and just remind you of something, just temporarily. This is not too critical, you don't need to follow along. I just want to remind you that in our original database yesterday morning, I had 3 users and they had age. And if you remember, at some point yesterday, I think I showed an aggregate, right? I did a sum of all their ages. I'll type that again. Select sum of age from customers. And if you are following along, remember this is an old database. It has ages in it as a column. And the total sum for this set is 78. And I'll put the original query on the screen in case you want to verify that the computer knows how to do math well. I assure you that it does. They're very good at that. That's why I call them computers. So 21 plus 28 plus 29 is 78. When your data table just contains a bunch of numbers or a bunch of values you want to aggregate on, this is the way to do it. You can put where clauses on here and you can change how this summing works. But you can also do, let's do count. We do count star in the second one. Count is as opposed to sum actually went to the 3 values of age and summed them. Count is actually quantity of rows participating. So there are 3 rows in the customers table, in this old customers table. So select count star, shows you a value of 3. That's the quantity of customers total. Sometimes you'll be able to write queries that simple. Once again, you might have an admin who says, you know, every time I want to log into the website, I want to see the total number of customers that are in my system. That's actually a very common request. The good news is that query is really easy to type. All right? If it had some sort of inactive flag on it, you could filter. This flag doesn't exist, so you don't need to type this. But they might say, only show me the active ones. There you go. That's the quantity of active ones. If that flag exists. It does not exist in this data set, so don't try to run that. It won't work. But there's a lot of ways you can do aggregation. So I wanted to remind you that I showed you that yesterday. I want you to sort of get back in your brain sum and count. Because I'm going to jump back to the tables we were just working on. So I'm going to close this window out. That was just a reminder digression there. Let's go back to this phone number table. So I have 4 phone numbers. This is back to the Echo database. So we're back to the live, most latest one. You can resume following along now. Once again, I can do count. What do you think I'll see?
3.
3, 4. Got a couple guesses out there. The bottom is the actual quantity of rows. so we will see a 4. There are 4 total phone numbers in there. Now I'm going to go back, I'm going to take the count back out, so we can just view the data raw again. Now there are no integers here to sum up, so I'm not going to do any sort of summing here. It really wouldn't make sense. But I want to reintroduce to you something I showed yesterday, which is group by. Group by, remember, is when you have a set of rows and you want to take the rows and based on something inside of them, which you get to choose, we want to form groups in that system. So I'm going to group by customer ID. So if you look at the raw data before I press F5, you can see customer ID is obviously 4 rows, so it's going to be 4 of them. There are 3 for customer ID 1, that's Bob. And there's only 1 for Alice. So if I wanted to answer the question, please show me all the customer IDs and the quantity of rows in which that customer ID appears, that's a group by. Now, sometimes when you're learning, it can be tough to decide, when do you use a group by? I don't really have a single sentence I can give you that's really concise and a perfect way to understand it. The way I view it is when I have a set of rows and I do need to form them into groups, right? And I want to ask questions about the individual groups, or more accurately, I want to get answers to questions about the individual groups. So in this case, let's pretend that the goal is to show me the customer IDs and how many phone numbers each customer ID has. So before I type the query or press F5, what would you project in your mind we would see in that final record set? How many rows would be in it? Harper, you're cheating. You got too many years experience. Your guesses don't count.
Guess 2.
2, and okay, and what would they look like?
Possibly 3.
Possibly 3, okay. I think 2 is the right answer. Let's stick with 2. You got 2, that's good. But what will we see? I've already told you what the customer wants to see. Customer ID and quantity. So how many columns are going to be there?
2.
2 columns. And what are their values?
3 and 1.
3 and 1. That sounds right to me. Let's try it out. So we're going to group by customer ID. Now I do want to tell you, I'm going to press F5 and it's going to break. You're going to see this error message often when you're doing group bys, especially when you're learning. It's going to give a big red message and say, blah, 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 not contained in either the aggregate or the group by clause. There are some rather constraining rules to remember. Here's what I tell people. Whenever you do a group by and you decide how you're going to group, you can group on multiple columns, but we're not going to do that yet. That's advanced. I just copy and paste. Whatever's in the group by, I replace the star with that, and this will run. Now, it's not finished. We have not completed the task, but we have gotten part of our query written. As I told you, I like to experiment with SQL Server. I sort of build my query up and I keep pressing F5 till it's what I want. I iterate through. It's not like I'm a magician where I'm just going to go boom and I type 1,000 lines. I type a couple at a time and I press F5. I recommend you do the same. So we took all the phone numbers, we did group them by customer ID, and it did collapse this record set is a collapsed version of all the customer IDs that appear in the set, which is customer IDs 1 and 2. Then what I get to do in the select is add a comma and bring in a new column. Now this column, because it's not participating in the group by itself, which means it's not typed here, must be an aggregate function or a fixed value. So I'm going to do count. Now a moment ago I showed you a count star on that old database and it was a count of all rows in the table. That's not what's going to happen here. In this case, it's first going to group and then do counts within the group, which is exactly what we were hoping to get. So if I press, in fact, I'm going to give it an alias so it makes sense. Quantity of phone numbers. I'm going to press F5. This is exactly what we wanted to see. You were correct, we had 4 rows, good job. I think you said we were going to have 2 columns, good job. And the values are 3 and 1. That is to say, customer ID number 1, which is Bob, has 3 phone numbers. Customer number 2, which is Alice, has 1 phone number. Right, so once again, we have taken all the data in the phone numbers table, of which there are 4 rows. You'll notice 3 plus 1 equals 4. That's not a coincidence. There are all 4 rows in the table. We grouped by customer ID, so there was a group of 3 and a group of 1, and then we asked in the T-SQL, please count those. Well, it gave us 3 and 1. There are other aggregate functions, but for starters, I just wanted to show that one. Okay? Any questions about that?
Just for fun, could we put the customer names next to it?
Could we put the customer names next to it? Now that is a challenge for me. Let's see. Well, the first thing we ask ourselves is, if there's two tables involved, what am I probably going to type? Join. Somebody said it over here in the back. Good job. It's definitely the customer table. It's got to have a join predicate. We always type that the same. I've typed them all the same since you've been watching. I'm not going to change that up on you or confuse you. Maybe this will work, maybe it won't. I don't even know. I'm going to press F5. Well, it successfully worked. The data looks the same, but what did I forget to do? I didn't select it. So the table's participating under the hood, but I didn't put it in the select clause. Remember, select is what I get to read. So since the numbers are the same, we probably typed the join correctly. We didn't break anything, but we are missing some data. So let's experiment and add in exactly what you wanted. I'm just going to put in first name. Now I happen to know this will break, so be ready for that. But it is going to break in the way I've already warned you about. It's going to give you a big red message, and they're always worded the same. Not contained in either the aggregate function or the group by clause. What this means is this right here that I have highlighted, the group by indicator here, does not perfectly match the set of columns that are not aggregate functions in the select. SQL is just strict about this. You just got to make them match. So whenever you see this big red message, blah blah blah, and the keywords to see here, not contained in either an aggregate function. That's how my brain is memorized. Every time I see that, I go, oops, I've either left something out of here or here. Right? They're somehow not in sync. They need to be identical. Fixing that is extremely easy. You take exactly what you typed in the select, I just copy and paste it. Now, the columns in the group by match the columns in the select statement, except for the aggregates. We get exactly what we wanted. We have the original record set, but we have an extra column, which is what you asked for, which is the customer name. But you'll notice how we built that sort of incrementally. We knew we needed a join because there's multiple tables, but that wasn't good enough. We went ahead and added what you wanted to see, which is first name in the select. We got an error. We made the group by match the select other than the aggregate functions, and voila, it works. You have a question?
Yeah, I just wanted to point out that in this example, imagine you have a giant table, right? There's probably going to be lots of Bob's analysis in it, in a big population. If you just grouped by first name, you're likely to get all of the Bobs kind of smushed together and all their phone numbers, right? Because that's not a unique enough grouping by.
Mm-hmm.
But by Derek putting the customer ID in there, it's like you guarantee that all those things are unique. Even though you're only showing the first name there, it's also grouped by customer ID. So you're going to see all the phone numbers exactly by that customer.
Yep.
Not by, all the Bobs or all the Alices, which you might want.
You might.
And then you would leave that customer ID off. But that's kind of a if you ever get into a situation where you're kind of seeing too much data or too little, think about how distinct your group by clause is, how exact that is.
Yep. I'm going to reiterate, since I have the microphone, for the other crew. I'm just going to quickly summarize what Harper said, in my own words, basically. We are joining here on customer ID. You would need to be careful in other products. If you do group bys on strings like first name, the real thing to remember is there could be multiple Bobs in the system, and if I'd written this a little bit differently, I could actually make it so that all Bobs got collapsed and it wasn't based on customer ID. But I did join on customer ID, so it works that way. If I may piggyback on that, if I'm a developer, I definitely want to see customer ID. You're going to want to focus on the primary keys being your way of joining and connecting data and guaranteeing uniqueness. Grouping on a string like a first name, even with a last name, you might think, well, there's not a whole lot of Bob Smiths in the world, but there are. And you don't ever want to make that assumption, so rely on those keys to keep things unique. I sort of used my own wording there for the people in Winston-Salem. Any questions? We saw group by yesterday. We've seen it again. I've re-showed it to you. Any questions about that?
Does the order matter for for group by?
Oh, good question. The question is, does order matter for the group by clause? The answer is yes. Actually, no, I'm thinking of order by.
Order by does.
I am incorrect.
Group by
It does not matter for group by. I got confused with order by. Remember yesterday I showed order by? You can put multiple columns in order by. That does work. It starts by ordering by the first, then the second. But for group by, it doesn't. I apologize. Other questions about group by or aggregating on groups? The group by is really going to pay off when you have lots of rows and you need to answer a question about subsets inside those rows, which we call groups. That's when it really pays off.
Yeah, I think the way to think about it is like summary reports. It's like if you want to
Yeah.
take a big table and create a summary report of something, minimum, maximum, average, count, sum, that type of thing. Like you want a compressed report. That's where you would use group by.
Yes. Harper, I just mentioned summary reports are where group bys really pay off, and I would agree with that. Yes, question?
Can you tell me what the on is doing there exactly?
Sure. The question is, what does the on do, which I will highlight. So when you do a join predicate, we're setting up in this presentation, in this discussions, we're setting up very simple relationships. We're always using the same column name. That's good practice. Hopefully you'll be doing that a lot. But apologize, my phone is not on go away mode. Do not disturb. Sorry about that. We're designing our system pretty well here so they always match. So our join bys will always, our join predicates will always be pretty straightforward. However, we're not actually constrained by the technology to do that. There are plenty of products where there will be a need to do joins that are not, they might not even be real relationships in the database. They're just relationships that are being contrived on the fly for whatever the current need is. So what this means is that SQL Server doesn't know how you want the tables to come together. It does know how it thinks they're related, because it has a foreign key relationship, which I told you yesterday is a solid relationship. You can't violate it. But it doesn't necessarily know that in this query that that's how the join should be accomplished. So whenever you have a join, you have to have an on. And the on is just say, join, and please use this as the connecting mechanism. Now for all of our examples, and all the examples I will show you till we're done talking about SQL, I'm not going to confuse this at all. I'm going to keep them P customer ID, C customer ID, or something similar. But you will end up, and I'll type something that's invalid, so don't follow along. There will be products out there where maybe this one is customer ID, but actually, let's leave that one the same. But under phone number, it might be some sort of, I'm just going to call it weird identifier. And I'm going to make this nice and confusing for you, just as an example. Some join clauses will have multiple predicates. They'll have something weird. I'll just make something up as well. Other value equals C dot some other value. Sometimes relationships that are contrived on the fly are actually composite column sets across tables. Now, I don't like people design databases this way personally. I try to make sure I don't ever design them that way, but inevitably they happen. They happen for many reasons, and in such cases, sometimes you have a query with a join or a set of joins that has needs that the technology can't guess. So we have to tell it how to join it, and the on clause is exactly where we do that. Do you have a comment, Harper?
I was just going to say, this is like if y'all remember from JavaScript where you're setting something equal to something, the if statement, right? You're testing a predicate, the Boolean true or false of it. That's all this is doing here. That's basically saying, join these tables together where weird identifier in this table equals customer ID in this table.
Yep.
So it kind of like, you think of these two grids like this, and where that match happens, it's like, okay, join these, get that result back. And you could do multiples, and you could do ands and ors, and kind of create whatever.
So it's strictly for specificity.
It's like truthiness. It's like checking the truthiness of those two tables lining up, and wherever that's true, it grabs that row from both the tables to be in your results.
Mm-hmm. So to reiterate for Winston-Salem, something Harper just pointed out, he's comparing these join predicates to the predicates in JavaScript where you're saying if something equals something then, and when this entire clause is true is when that customer row does get plopped onto that phone number row. That's when the join is considered matched and they go. And I just went ahead and pointed out that I was doing it while you were talking. You can also use inequalities and other operators here. You can do anything. My hope is that you will not be in a position too often in your career where you have to do crazy join predicates. They happen inevitably. Usually, though, it's actually just a bad design decision, in my personal opinion. In the vast majority of cases, let's get all this noise off the screen. In a well-designed database, all of them look pretty much like this. If it's extremely well-designed, the column names match, and they actually represent a real foreign key relationship that already exists, and these join predicates become tedious to type but very simple. But that's why there exists an on, because it's not necessarily going to be a previously known perfect relationship that we're joining based on. All the examples I will ever show you will look like this. I'm not going to show you advanced ones because I don't want to show how to not do work well. It's possible and I don't want you to do it. But you will run into it. Just be ready for crazy ons and just shrug your shoulders and keep working. It's a good question though. Yeah, just defining the predicate. And in case it's not clear, this predicate's evaluated row by row. So it looks at phone number 1, pulls customer 2, and checks that predicate. It goes, are they the same? And if not, the join isn't matched. But once it hits phone number with customer ID 1, which is Bob, and the other customer it's looking at the moment is also Bob, 1 equals 1, that's a match, that row matches. And it's doing that. Now that's the way I'm going to word it. It's actually much more efficient than what I just said. It has some crazy efficiencies that are much faster than you could write the join yourself in like a language like JavaScript. Other questions about group by or aggregate functions? These are great questions. I really like them. Even the challenging one. I want more. You gave me give me more. We're able to make that happen. Okay. So that, I think, is enough to cover for phone numbers. I know we went backwards a step there because we ended yesterday with the favorites, but I wanted to come back to a very straightforward one-to-many that we had already done an exercise with and revisit group bys and really introduce that left join, right join mechanism. Left join and right joins are very common, and group by is very common. You'll be typing it quite a bit in the database world. They're the real meat of the product. They're really powerful, so they're going to be doing that a lot. Let me look at my notes here real quick. Oh, that's still phone number. That's not what I want. It's time to go back to favorites. That's what it's time to go to. So we're going to switch gears back to favorites. And I want to remind everyone of those tables. So let me just open up a new query window and select again. Once again, we got, where are we? Wrong database. Go back to Echo. We got customer. We got products. These are two separate tables. There's no direct relationship between them. Notice that nowhere in customer is a pointer to product, nowhere in product is there a pointer to customer. They're completely isolated, but there is a table in between them. Remember we brought that new table in. It's got 2 foreign keys, and it links all that stuff together. I'm now going to move my picture up because I'm going to have data in the bottom often right now. Hopefully that's good for the peeps in Winston-Salem. There we go. So just as a reminder, we got 3 customers, we got 3 products, we have 3 favorite records. So Bob, we can just do this manually by looking at it with our eyes. Bob has favorited the car. Bob has favorited the camera. Alice has favorited the camera. So we have 3 favorites, right? And that's how we've linked this all together. I'm going to retype something I think I typed yesterday. So that's our base data. I'll go back to this query window whenever I feel like we want to remember what the state of the data is. But let's do a new window and type something. What did I showed yesterday Select all favorite products for a given customer ID. Let's do that one again, just so we pick up exactly where we left off. We know we're in the favorites table because that's the nature of the question. The application developer came to us as a DBA and said, I want some sort of report that shows me all favorite products for a single customer. So we know we're going to the favorites table. Question?
Yeah, I'm sorry. When we went through this yesterday, I was following along with what you did, but could we go back through how to link up the IDs for like all the way back to making a table? Because we kind of started cruising at the end of the day yesterday.
Sure. So the question is, can we revisit how to build a many-to-many? And I might not actually build it from scratch, but I'm going to open the table and review exactly how we designed it. I will open in the designer. So we opened the designer, we created a new table. Obviously we gave it a primary key. You always do that. We're always going to be doing that from now on. We named it favorite ID, we saved the table. It's a primary key, it's identity 11. So that first column should never be a surprise for the remainder of our chats. Right? There's always a primary key. I'm always going to make it identity 11. I'm not going to change that on you ever. It's possible to do more advanced things out of the scope for us. When we did the phone numbers table, we put a customer ID on it. Right? So customer ID int, not null. We went to the relationships. Now in Winston-Salem, I'm going to the top right once again. So let me move my camera down. Boop.
Should probably just put it on the top left so it's not.
I'm worried about the Object Explorer. I think I'm going to have to keep moving it around. But I go to the top right here for relationships. And we added the first one, favorite customer. We did the same thing for phone numbers already. So that was repetition for us. We went to the table specification. And we use this UI. The foreign key is always the one you're working on, because children always point to parents. You can't actually change this value because foreign keys are always about children pointing to parents. I selected customer here and I made them match customer ID, customer ID. Now we had already done that for phone numbers, so that wasn't new. What was new is we added a second column on the table. I'm going to keep this UI open for a second. We added product ID to the table and then went to relationships and added product. We added it the same way. We just didn't connect to the customers table. We made, and I'll go back to the pop-up, foreign key is still favorite, but we made it point at the product table on product ID. So now it has two parents. And once again, remember how phone numbers is laid out. Customers can have 0, 1, or many phone numbers. That's a one-to-many. Phone numbers don't point to customer. I'm sorry. Phone numbers do point to customer. Customers don't point down though. So you're going to have a customer that has 0 phone numbers. When we built this favorite table, we did the same thing, we just did it twice. This table points to 2 others. And the reason we did that is so one customer could favorite any number of products, and any product can be favorited by any number of customers. That lookup table in the middle allows it to be a many-to-many. So many-to-manys are just one-to-manys done twice over. And that's how we built that table. Today I'm going to be adding some more columns to it, but initially I just wanted to show that it's got its own primary key and 2 foreign keys. And it stores just enough data to relate to tables that originally were not related. Remember that customers don't actually have a product ID anywhere in them. Products don't have any customers in them. This table has both pointers and connects them. This allows us to write some queries, which is what I'm about to write.
And if I wanted to make Bob's favorite product a car, I would write in the query. I don't quite.
The question is, how did I get the data in a state to where Bob favorited the car? I did a simple insert statement on the favorite. I will type it again, but I'm not going to run it. So insert into favorites. This is the customer. Obviously, that would be Bob, and the product that he likes. And we put in, that should be on a new line. We put in the new values. I'm not going to press, actually I will press F5, we'll see it break. Mine's going to break because I put on that index as well yesterday. I put on that index to enforce uniqueness. I didn't want Bob to be allowed to favorite twice. Something's either a favorite or it's not. If you allow duplicate rows, other queries developers might write later will come back with weird data. If you think about the aggregation that we did, where we were counting favorites, where we were counting phone numbers, I could write a group by or some sort of aggregation over favorites, and if I allowed duplicates, if Bob favorited it twice, it would say he has 2 favorites. But they're both the car, so that wouldn't make sense. the way I, as a DBA, prevent future queries from accidentally returning bad data is I've got a unique index on there. He can either favorite the car or not. It basically turns it into Boolean instead of an integer quantity of results. So yesterday I typed an insert statement, 3 times to give 3 favorites? I'll find the window in a second. But that's what I did. So that's how we got to the favorites position. Hopefully that's good enough because I need to move on a little bit. But that's how we got there. Yes, Harper?
You have a question about, can you look at the index for unique?
Sure.
Uniqueness?
Sure. People want to see the index, no problem. That's not where I put it. Wrong table. So on the actual favorite table, there's a bunch of little folder icons here. I'm expanding indexes. You will always see, by the way, when we put on those primary keys, that, as I said at the beginning of yesterday, is a clustering key. Primary keys are a clustered index. Don't worry too much about the terminology of clustered versus non-clustered. The only thing to remember is there can only be one clustered, and it's always the primary key. That's the way to memorize it. That one's always there, but I added this extra index, and the sorry, my computer has slowed down. Remember that if you're using the Express version, they were not able to do this. This is probably why the question's coming in. I did this yesterday only while people were watching. I have the dev version of SQL Server on my machine, so I have more features available to me than some of you do. But I did right-click and do a new index. I ended up with this index, and its shape is, waiting on it to open. I indexed on both of those foreign key columns. I'm going to highlight that. That's where that is on the screen. And I check-marked, I'm moving the mouse around, that unique checkbox. So I told you yesterday the analogy of the book with the index in the back. The main power of indexes is for read performance, for seeking to certain values and finding where they are in the data set. But there are other uses of indexes, and in this case, I'm putting one on not to make the read performance better, although that does happen as a result of putting index on. My primary goal was to make it unique. And that's just how SQL does it. If you think about it, that was their best way to implement unique, because the way you enforce uniqueness is to scan the whole data set and see if there's another one. Well, I just said scan the whole data set. That should be a red flag to you in your path to becoming a database person. That's not performant. That's very slow. If I had 1 billion records in the table and I wanted to check uniqueness on the 1,000,001st record, I would need to scan 1 billion of them. Well, they use an index, so they don't have to do that. If they go ahead and build an index of the 2 values, they can very quickly answer the question, does it exist in the index, much faster than scanning the whole table for those values. So it might seem weird that uniqueness is index enforced until you realize that that is the most performant way to do it. I'll reemphasize, the databases are built not just to store data, but to store it well and perform well under heavy load. SQL Server is a global product. It's an enterprise level product. It's something someone the size of Twitter or Facebook could potentially use to store some of their data. And you have that much throughput, you have to do some crazy things to keep the performance good. And that's what they've done. As I said, you might right click on indexes, and this new index is grayed out. It's because you don't have the same version I do. Sorry. If you do want to play with SQL more on your free time, my suggestion is to download to grab the dev version. The dev version has all the features, at least as of a year or 2 ago. It has all the features of the Enterprise Edition. It's just illegal to use as a production product. So they basically give you the whole product. You're just licensed. You're constrained not to use it on an actual server. So and it was very cheap. It's like $20 or something when I got it. It's nothing. Question?
I have the 2014, just the Express version, and
Okay.
I think it lets you do indexes. I can do it.
I suspect that some people were saying they could do it yesterday too, but only if they had the query windows closed out. And I suspect it might be like a connections thing on Express. Where
Gotcha.
It's like, maybe. I don't know.
Gotcha. So some people could do it and some people couldn't. Well, if you
Not
can
being
do
able
it.
to do indexes is kind of basic. Like you should be able to, So I think there's a
I
way
agree.
to do it. Yeah.
I agree. I mean, it makes me tempted on the people who have it grayed out if I could just open a new window and type the script for it, and it would just run.
Yeah.
So you might have that ability. But if you didn't, I don't want you to get worried. We're not going to be focusing much more on indexes. I just wanted to tell you that they exist, give you the analogy of the book, and I showed you here that they're a way to enforce uniqueness. There's a lot more cool stuff to learn about indexes, but I don't have time to cover it. So let's see, where was I? I had here. I was going back to favorites to do that example. So here's our data. Let's remind ourselves, got 3 customers, 3 favorites. Bob has favorited 2 of them. Alice has favorited 1. So here's starting off with a simple query. We'll run it. Here are the favorites record that I did 3 inserts yesterday, just by itself. Let me remind myself what my goal here. List all. All right. The developer came to us. List all favorite products for a given customer ID. So that's all favorites. This is clearly not the correct query yet. What do I need to add to it? Joins. You would need a join if you went to another table, but per what we've been asked for, list all the favorite products. We might need the product name. Is that what you were thinking? Maybe product name? We'll put product name on there. Let's do that. Let's be sure to spell it correctly. Product ID, p.product ID. So press F5. That's good. So now we have the product name. Remember, we're sort of building this incrementally. This is how I actually write queries. I don't write them correctly the first time. I just keep building it till it's correct. So we've got all the product names, but it says for a given customer ID. Clearly, we've got too many records on here. How do we filter out records? Anyone? What's that? We got to select. Select is which columns we want to view after the selection, after the filtering has occurred. So this is missing a filter. What keyword do we use for filtering? Where. Where favorite.customer ID equals, and we'll just pick Bob since he has 2 of them. And that is actually the correct data set, right? This is all of Bob's favorites. Remember, he favorited car and camera. We have a lot of extra columns on here. We got a couple duplicates. So let's go back to that select star and trim that down to just the columns we care about, because this is the correct record set, but it's got too many columns. In fact, I'll point out many once we get into code and how we read data from databases, whenever you have duplicate column names, that can be a real big problem. Many times the way in the code, it's going to be JavaScript, or I'll be showing you some C# in about a week. If we try to access these columns based on name, it doesn't work, right? Because although product ID is correct in both of them, and they're both 1 and 3, in code it'll say something like ambiguous column name. Big fancy term for it. It's got 2 of them. I don't know which one you want. So one of the things we do with queries is once we get the query down to the correct records with the correct data in it, we trim it down by turning that select star into something else. So let's pick for a given customer ID. So all it needs is product. Let's pick p.product ID and p.product name. Because per what the developer wanted, it explicitly said list all favorite products for a given customer ID. So they don't even want the original customer ID back. That is a really good record set. This meets the needs of what we were asked for. List all of the favorited products for a given customer ID. And we have trimmed it down to just the columns that are relevant. We're always going to want to give back the primary key. Get in a habit of giving that back. You might have wanted to only give back product name. There's nothing wrong with that, but the problem is once they show that on the UI, what if the purpose was to perform an action on it? Well, that means the next query that comes in is just going to have the word camera. We might have 2 products named camera. Like we as a database guy, we're like, no, we can't. You can't just give me just the product name. I want the ID. So our responsibility with select statements is to make sure we are always giving back product IDs, even if the app developer does not ask for it. I always give back. If it says list all favorite products, I'm already saying I'm at least going to give them a product ID back. That way subsequent queries have a number. Remember, that number is really important. I could put a pun in here about how it's a key sort of a feature of the data. It's a primary key. It's a unique identifier enforced at the database level. It's never going to be duplicated. It's never going to be wrong. And to be academic about it, it's a one-to-one relationship with all of its corresponding data. Yesterday, Ali used the term surrogate key. It's a more technical term, and it's accurate. These primary keys, you want to be passing them around all the time. They are your handle on the rest of that row. Don't ever try to guess the row based on like uniqueness of a set of its columns. You don't want to do that. It'll bite you one day. And when it does bite you, you're going to lose a lot of time. So just stick with those keys. So always get back to product ID, which I'm doing there in that first column. And of course they wanted the products. They probably want the string too, right? The pretty name, human readable name, car and camera. This is how we satisfy list all favorite products for a given customer ID. Okay? Questions about what I've typed here? I didn't show you anything new. I'm just on a new set of tables. We've already talked about froms, joins, and wheres, and select. Cool? I think what I would like to do now is have a little exercise time in a moment.
Yeah.
What you got, Harper?
Just as you go to exercise, there's been a request to grab the Echo database kind of in its current state, because I think some people have kind of gotten behind on doing that. So if it's going to be based on something that already exists,
Yes.
if we could script that database out and make that available in Slack, that way people can kind of rehydrate kind of
Okay.
a known state before they start working.
Well, let's use this as a moment. Do they want just the schema, or do they want the data too?
Probably both, yeah.
All right, well, let's start with schema. So everybody heard the request in this room here. So let's talk about that. There's a few ways I could do it. If you remember yesterday, let me collapse tables here. I'd already showed how to make SSMS script out your schema. So we could do that with customer. Create a new window. And I could do this 3 times, and we might end up with that. I might do customer, product, and favorite, and we get this big old set of text, but it's written it out. We can copy and paste this. People can execute it. Just to show you it's possible, and you don't need to follow along. Just want to show you it's possible. That's going to work today because there's only really 3 tables. But I right-clicked on Echo and did generate scripts. There are actually quite a few features that allow you to do things in bulk, some higher level things. If you think about it, what if I had 1,000 tables? Would I want to right-click and script to new window 1,000 times and do 1,000 copies and paste? No, I would not. So I can actually generate sets of scripts. So I have customer, favorite, let's take out phone number, let's take out the do item. That way we're talking just about the current exercise. I'm just showing you this is possible. Save the new query window. This wizard sometimes breaks, so if it breaks, please don't be too disappointed. It's very picky. I've found it's very fragile. But it successfully ran. I can do finish, it'll close, and it's actually scripted all 3 tables out for me. So I showed you how to do it manually one at a time, but I'm also showing there's a lot of cool tools and ways to do this in bulk. And now I could probably copy and paste this for... Do you want me to copy and paste it as... Can I upload a file? I'd really give them a SQL file.
Yeah, you can upload an attachment to Slack, yep.
Cool, let's do that. So that's another teachable moment.
Just one thing, that it says use Echo at the top, so if they already have an Echo, it's gonna be like, hey, I can't insert all this stuff.
Right.
So if they already have Echo, they should just name that something else.
Yeah, so I'll highlight the part that if you've named your database something other than Echo, you would just change that at the top.
And then make a new database called whatever that is.
So what use doesn't create the database, you will need to have created it yourself, but if it's empty, this will then work as long as you change the name correctly. I also want to point out, since we're at this moment, you'll notice whenever we create a new script window, at the top left, it actually has what looks like a file name. It's a temporary sort of quickie file name, SQL query 18. All of these queries are just text files under the hood, so we can save this at any point. So anything that we've been doing, I probably should have talked with this earlier today so you could save some of your cool stuff. You can do save as. It has some default location. We'll call this the Echo database tables and save it. And before I post it, I'm going to go locally on my system and reinforce something. I want to remove some magic. A lot of times when you're learning about software, things can appear really magical, and that can be intimidating. That's that SQL file I just saved. Notice it's date stamped 9:32 a.m. I'm going to open this with a text editor and show you. It's not magical. It's not a binary file like an image file or your PDFs. It's just plain text. SQL is all just plain text. If you open up Notepad, or what's the text editor on a Mac?
Yeah, text edit. Yeah.
Text edit. You open that, you start typing. You can actually type all SQL you need, DDL and DML, in plain text files. You won't get the cool coloring, which is why I like to use SSMS with all the blues and the grays and the pink colors. Some of the colors can be really helpful, but they're just text files. So I wanted to remove that magic. There's nothing happening. It doesn't turn this into other code. When I talk about C# next week, I'm going to be talking a lot about how code gets transformed into machine language, which is really complicated stuff. SQL doesn't do that. It's all text all the time, plain text files. So now that I've done that, let me honor the request. I'll open Slack, and I'm not sure I've ever put a file up on Slack, so you might need to either tell me or hopefully it's easy.
Just push the little plus button to kind of attach
Little plus somewhere? All right.
And put it in code if you don't mind.
In the code channel, okay. So let me copy and paste our location locally. It's where you don't have to follow me on this. I'm just showing you what I'm doing because that's where my SQL file is.
And for anybody who wants to save, like if you're working on exercises today, just make a new folder in your Empower folder, like where we've been saving all our code, just to have like SQL, and then day 6, day 7 if you want to. And that way, as you save things you're working on, selects and stuff like that, you kind of can go back and look at some examples if you want.
I think you're right about the Slack and the performance hit. Slack's taking a moment to open. When I'm streaming it, this is not a powerful laptop, so it's slowing down a little bit.
Yeah, they may have seen some stuttering on the side.
Yep. I'll get the script posted and then I'll describe the exercise while people are running it. You said in code?
Yep.
All right.
And there's still a little plus button down there, down at the bottom. Yep.
Gotcha. Add file from my computer. Perfect. I'll paste the location. There we go. Change echo database name. Awesome. Easy enough. And so you can easily run that. All you'll do is you'll go to, in SSMS, you'll go to File, Open, and find that file wherever you're going to be saving it. And it will look just like this. Be sure to change echo to your database name and press F5. It will have all 3 tables. So if you have only the customer table and not the other 2, you'll probably just want to either create a new database or drop that original customer table. I only gave the schema here.
Yeah.
So
there's the do the same thing. There's like a data export wizard essentially.
Is that same thing generate?
Yeah.
I don't do data export as often.
Yeah. It's see if those same ones and see.
Yep.
If
Customer favorite product.
Export.
I bet it's in here, isn't it?
It might be a see, schema only. Yeah. Type of data descript. See schema only there.
Yep.
Change data only. Yeah.
I'll do both next time, but I will give him the data. I could just say, I'll go to new query window so we can see it.
Generally, when it gets fussy, especially on a big table, sometimes it doesn't know how to do cross-reference.
Yeah.
Right?
So we scripted out the schema, so you'll at least have that. But I'm going to try to do the data here. Looks very happy with that. You can see it's generating all the insert statements for me. Once again, it'll have echo. So I'll do the exact same thing. I'll save the data. Data file. Echo database data. And I'll put that in Slack as well. Change echo. You gotta do the same thing. Make sure it targets the right data. And you gotta obviously put the tables in before the data. You can't put the data in first. All right. So everybody now can have an exact copy of what I've created with the exact same data. All right. And so let me describe, and I will type these since I'm now in Slack. I'll type these for everybody. But I'm just going to verbally go down what I'd like you to do. It's going to be the same 3 tables. Here's some exercises to try. If you didn't follow along, please do the first one I did. List all favorite products for a given customer ID. But you saw me do that one live. That shouldn't be too difficult. I want the opposite. So as an exercise, list all the customers that have favorited a given product ID. So you're going to have a product ID, and I want to see all the customers that have favorited that particular product. The next will be, let's do list all customers that have at least one favorite product. So I just want to see a customer list that shows just people who have favorited at least one thing, no matter what it is. Then let's do the opposite. List all customers that have no favorite products. This is a report of customers that don't like our favoriting feature. For some reason, our boss wants a copy of that report. So let's do that. And let's do the opposite of that. List all the products that have never been favorited. So these are products that our customers hate. And we want to report and try to figure out why do those products never get favorited. That's good enough. Let's go with that. Are you typing it?
I'm just going to put the list in, yeah.
Okay, well, I'm going to have to help you because I skipped a few.
Okay.
I'm not doing all the ones, just based on the phone.
Gotcha. Yeah, they just requested it.
Did you type anything?
Nope.
Okay, then I'll type them all.
Okay.
I got it. I'll type all the ones I can.
Or just do exercise there at the front, just so you kind of know it's, yeah.
Okay.
Where's the schema posted?
It's in the code channel.
Oh.
On
Just look it up.
Power Slide.
On the code. Oh. I guess I never went in that one.
What channel?
I have channels. I don't have a code. Now I do. Whoop whoop. Glad to help.
So before I go out and just grab what's it on, I just want to see if I actually did this right. When you put in foreign key, the first one from the table is pointing out to
Yep.
whatever it references.
Yep, you got it.
So that's
Yep.
I got that one right.
Mhm.
Cool.
Yep. I think you need the foreign key name though, like what you want to call it, I think. Actually, in an add foreign key, do you need to tell it a name? Or does it just make one for you if you don't tell it? Like, is that valid, or do you need to add like a foreign key name of what you want to call it? Or does it just make one for you if you don't?
I don't remember. My guess is it makes one for you.
My guess is that too, yeah.
It makes an ugly one. But it works.
Well, since you're gonna grab it anyway, but yeah, I think if you don't, like, you can specify a name there, add foreign key, usually it's like FT underscore, like, it sort of describes what
Where
foreign key
it's
is.
pointing.
Yeah, and that way, like, when you're looking for your keys list, it's like when usually you're gonna have a lot of them in a table, and, sophisticated database, you're gonna have like 3 or 4 foreign keys maybe in a table, and that way, just by reading it, you know which one it is, talking about. That way, also, if you name them consistently,
So would it
if
be
you're using
like-
scripts to update them and stuff like that, you know how to find them again to get a reference to them. You need to change them.
So would you do like add foreign key, product ID, name, whatever?
I'm not sure. Do Google for T-SQL, add foreign key, and it'll show you the exact. Yeah. Okay. So I would go to that. I would go to the SQL. I would type in T-SQL, add foreign key, and look at Microsoft's documentation. Because those are going to be, the only problem with those is like the things that look at multiple databases, they're going to be very general.
Yep.
Yeah, look at or Stack Overflow. That's probably easy. Okay, so scroll down where they show that answer. Do it is probably going to be like whatever having a lot of numbers on it. It's checked. So keep going. So 2 answers. And that one's checked. Has a bunch of numbers. That's probably okay. So long. Foreign key. See, they've got the name there, and then foreign key reference, blah blah. So that's like
So constraint.
That's how you do it. Yeah. Add constraint is just another way of saying like add foreign key. I mean, it's just a type of constraint. There's foreign key constraints. There's uniqueness constraints. There's a bunch of different kinds. But that's how you would kind of name it if you want to. Or you can use it, in the UI. You can kind of it creates that little name for you.
I'm not even going to try to dance with that UI. I have no desire.
Good decision. If you script it out, it'll work anywhere, right? I mean, if you script it out, you can do it from anywhere. Yeah, so close up test.
So did you open those queries? Did you run them?
Minimize
Did
that.
you run the table
Just
script?
all the way at the top. Yep.
Okay.
I think it's easier there.
So your echo is currently blank,
You want-
right?
I've been doing that all day,
Okay,
like
let's
getting
get
the database. All right, so close up.
Let's
those
refresh
two
the database
tabs.
just to make sure.
All those databases can hide them. Yeah. All right. So you're gonna want to create a new database. If
Yeah.
you wanna,
So as long as
you
your
wanna
target
use this
echo
and call it Echo, then right click on
to
database.
the table script. This is the data script. We have to run the table script first.
Call it Echo.
Is that one it?
Yeah.
Okay, yeah. So press F5. Should be able to run that. It worked. We go right to the data. Press F5. That should work. It did because we got green. It's a long list, but it says green. We're good. But if you refresh, you should have all the tables. All three of them
Take a second,
populated
and
with the same data I have.
Then what you want to do is click on this script here, just anywhere in there. Sorry, yeah, and then pick your database up there that you're pointing to. So you use Echo. And that little, okay, close up here. Up, a little more.
Oh, okay, oh, that's
See
right.
that little
Oh,
drop
okay.
down
Oh,
list?
okay.
That's kind of where you're pointing at, so you want to pick it up there.
Okay.
Yeah. And run it, and it will, that script will make those tables in that database. So right now it's empty. Like if you look under tables, you can expand the table. It's gonna be like, there's nothing in there. After you run that script, there'll be those, and you refresh tables, there'll be those three tables in there.
Okay.
And then if you run that data script, they'll put all the data in there. that you need.
Put the script right here.
Oh, that's the data.
We're gonna do the tables first, yeah, you do the tables first, and then all.
Oh,
What's
this
this?
is the data script. We have to run the table script.
Yeah, it is the latest one, but you need both of them. That's gonna go wherever you have your download. I don't know.
We can run this data first, since the other script I don't know which route we're to. Table script.
Yeah, so you save it, like this. I deleted my old one, so I can save this one. That's Echo. So refresh.
Okay, so now I'll open this. I open this now.
Yeah.
You can open that in SQL Server Management Studio so that you can run those scripts in. And the only thing you'll need to do is create that Echo
Did you run
database.
the table first?
So you do?
Yeah.
There's nothing in it. No. Run this to open your SQL
the one that you
editor.
downloaded?
You already got it
Like the two
open down
files?
there. So go ahead and open that.
Oh,
and then
you gotta
from
go
it-
to-
from inside there,
Yeah,
do
yeah,
file and
I'll
open.
open it.
And go find it. You have to go to the file.
Okay.
Yeah.
And then we can find.
Just file that one. Yep. And then just go to your downloads folder and find that. And you want the schema one first, and run that in Echo, and then do the data one. Then you should be good to go.
Which one's the schema? They're all kind of. Oh, this table. I'll be back in just a second. How long do you think this one should go?
Average, I don't know, 15, 20 minutes.
Okay. Alright, so this is right
Thank you. All we needed.
Thank you.
Yep.
Oh, no, everything's good.
Okay.
Yeah, I was telling you, she learned how to say thank you in English.
Oh, okay.
Just to mix it up.
In German it's Danke.
No.
Danke.
Yeah. Danke.
I don't like it in French. Merci.
Spanish we have gracias, right?
De nada. Anytime.
I think Russian it's spasiba. Yeah, I think it's spasiba. Been a lot of years since I knew any other languages to any degree.
questions.
Okay.
Yeah. Yeah, that's all these are.
I sort of left it,
Yep.
but I didn't actually show the technique yet. But obviously, I'm going to do the exercise.
Yep. I think that's the thing. Like that approach. Write it right in the comments, like this is what I'm gonna do.
Right, just so I can see it go back to it.
Yeah. I mean, if you have any questions, stuff on anything.
So which one was
Oh, you watching? Okay. Who's playing? What is that plus 5 mean?
You're just gonna have to use the IVs for
There's injuries or whatever.
just make sure that if you're not using
Ah, that's interesting.
Yeah, that's 90, so it's not 90.
just make sure you have enough.
So somebody got injured. So
Oh.
they
Yeah,
had
they
to find
kind of like satisfy
So like 95, that's
You
something.
know, have to look at kind of back with these
Right.
from the other two tables.
Got a
to see
question.
kind of how to make that favorite table.
Yeah, first one works, that's fun. This one, so I need to select from my list of customers. Now, if they're not linked to their
How do I get my
Mhm.
thing so I always see the
So I have to use the phone key.
So if it's switched over, there's like
Yes,
a little.
That's accurate.
Yeah, a little stuff if you want my results to go over a little bit.
I've got
I think the
4
right one is
people,
next one.
so I was just adding random stuff in here,
One last
who don't
Like
have,
that?
who aren't on this list, so
If you gotta select.
I just don't know how I should choose.
So, just remind me which of these does this?
Well, that's all how I did it out.
Have no favorites.
What were you
Right.
running for then?
Well, I just like clearing
So
it up.
obviously,
yeah,
my query
doesn't work.
So.
It's not
it'll
enough.
be-
That's
if
right.
If you're writing.
Favorite
things
is no,
in,
yeah,
like,
right.
Grade tables. and
So let's talk about why it doesn't.
It's
Because the
not
favorite
writing
table doesn't
results,
know
right? Because that's
which
just
customers
like-
exist.
It'll just say.
Or more
how many
accurately,
numbers
it doesn't know
Like,
who
all
needs
updated.
it. It only knows the ones that have
You're doing a
favorites.
select. you're
somehow
getting data
get,
out, that's when it'll show, like, the thing there.
a list
But
of
you
customers
did have
who
it set, I
have-
think,
who have
to
no
result to
customer
text,
ID.
which it kind of displays like a text view of a grid out there.
Yeah.
So
I
I
like
would
results,
select-
I like that view, because it kind of
So
shows.
let's think about my phone number example.
C dot.
But that's just a preference,
Yeah,
it can
let's
do it
think
either
about
way.
Yeah, so remember the phone
Those are your
number?
results
I did
file.
a query and we
So
saw
it'll
all
create
the
like an
phone
output
numbers,
for you.
but Charlie was missing.
So if I did
How did I
select
bring
all
Charlie
and then
in?
from like my database and then hit
What technique
that
did I
button,
use?
it should show
It was a
up
new
like-
keyword.
Try just to select start from one of the tables.
Well, I might have, I don't think I showed it yesterday, I think it was brand new.
What's up? Cool.
Right join.
Right join.
One of the two. Yeah, they both do the same thing. It doesn't matter which one you type. It matters the order of the tables.
Add the data in.
But that's what we're going to need. You're going to have to reuse that technique we used on the phone. Remember, I brought Charlie in. Remember, you saw all the nulls.
Uh-huh.
So you're basically using the same
And
technique,
then,
right? We need all the customers. Is that what it is?
Yeah, you're good
It's
on
all
that.
customers.
You got
Just
that
like I had all
selected.
customers with their phone numbers, including the people without phone numbers. We do the same thing here.
Now just
All
hit
customers.
execute or
We're going to use a you're going to end up with a where clause that constrains it, so it's only the Charlies. Now I didn't show that example. Remember how
So now you
four
should
rows
have
and
data.
Charlie
Now
came
you got
in.
the tables,
I could
and
have
you
tweaked
got
that
the data.
query
And now you can just open a new query window.
I would have left it right
and
join, but I could have stripped out the four records that were a match, in which case it would have been no Charlie. I would have one row in it. And that's essentially what you're, excuse me, going to try to do here.
Okay.
So we definitely have to bring the customers table. It's definitely going to be either a right or left
You already
join,
do the tables one.
and you're probably going to need a where clause.
So then do the data. So you
Sure, rest.
click on refresh on your
So at
table.
least get it involved. Bring that table in and then maybe press F5 a few times and stare at it and see if we can make progress.
Yeah, on tables.
Oh, on
Click on the
tables.
table.
Okay,
You just right click and you refresh.
That's not gonna, that's gonna give me a. That's not favorite.
So.
I have to go get them, because I have the first.
I'm not sure where this is.
So this is a good start.
Yeah.
Obviously, we're not finished, but it's a great start. But we also know that the customer table alone cannot answer the question, because the question is about favorites. So at a bare minimum, we're going to bring it to
Join.
Or
Are those phrased?
Yeah. Now you got X.
So this is two.
Let's go back to just one. Yeah. All right, so now, so you've already got.
There's
your
product.
so
This is
this
the one where we only have products that have
All
been
right, so
favorited.
now, refresh the
Mhm.
table.
So our customers love cameras and Jella.
Refresh. Cool. So now we're going to put the data in there. So you've already got the table, the schema, it's called.
Sure.
Tables and all the underlying structure. Now
I
you're
have
going to
that
put
on.
so here you put a file.
I'm sorry. What happens if I just do that?
Should just be the same place. Now this time pick data. Yeah, you need the one.
Oh, yeah, okay, so I'll make sure.
That's
It's
just
the same.
where
And now you're already in that.
favorite product ID equals
Mhm.
product
So I
ID.
have to remember to refresh.
So this one does.
Yeah.
That's cute, it puts something else up there, like,
Where?
And now you can just close that out. You're done with that.
Close this.
Close your file, close that out. All right, so now
Okay.
you do new query.
So this is just selecting everything that Alice,
All the way to the top.
I think, has
Yes, it
in
is.
favor.
Yep.
Where customer two is
Mhm.
Right.
All right, so
So
now,
that's
now
where
you've got your
product
tables
ID
in here, and
favorite
data's
is
in here.
equals.
So now you can look in Slack in the exercises.
So do I need this equal sign, or can I just
And
do
and
join
the,
product
little
P
bar,
or?
so do the selects to get data out.
Join predicates are always,
And go into question.
join clauses are like a set of predicates, you have one.
So
That predicate is a Boolean evaluation. So it's always going to be either inequality or an
So you want to
inequality.
list all favorite products for a given customer ID.
It won't always be
So
equal,
you
but it
say,
almost always is.
In your products table,
You can't leave it out because
you're gonna have to join.
you need to
your
tell it how to
products.
do the join. It doesn't actually naturally.
And then you're gonna wanna say, get your customer ID and then kind of all the favorite, all the product names for a given customer.
So I'll give you a tip here. Although, if you look at the nature of actually the text version of the question, list all customers that have no favorites. The word product never appears. So I don't think you need the product table.
Right.
The only two nouns that appear in that question are customers and favorites, which means that's probably the only two tables you need. Products are actually more distracting for you.
Well, it's, like I said, it's funny, different people have, and that's what I was saying, it's like, if you like the web stuff, this may be like your customer. Didn't like that, or if that was hard, this may be sort of web stuff more than. Well, the thing is that,
Let's see what
like,
happens.
it's only been one day, no matter what.
Then see where we are.
There's like select.
So I've got it.
Because once you get those couple things down, and it just wraps
So
up.
I will tell you, you're on the right path. We're definitely not there, but you're closer now than you were.
Customer IDs. This is customer IDs that have favorites.
Exactly. This is the opposite of what you want.
Great.
But you have the correct tables involved. You're close, right?
All right.
You're on the right
Keyword
path.
opposite.
No. That's actually a funny way to look at it. But let's think back to the phone number example. Charlie had no phone numbers, but I got him into the record set. How did I do that?
All the information.
Boy,
is like where.
I would be a little closer to the answer if I remembered that. Maybe I have some
Wall and
other
all everything else is like, it's kind of it's the brains of the application.
Yeah. Say customer ID to.
But the news is, like I said.
Okay, so
once
it's
you
the
have
exercises from yesterday. Doesn't look helpful.
There's only so many things, and then it's just practice done. Okay, so.
So I'll remind you where we were with phone numbers.
Remember the right
Add the words left or right.
where it's like,
to the
show me
front of the
all
door.
customers,
You have to pick
even if
one.
they don't have phone numbers.
The way you pick
So, but
is
you
whichever
remember
table
how
you
it
want
showed all the
everything
customers,
from
and then their phone numbers,
is the
and then
direction
once
you
you
point
didn't have
at.
phone numbers,
So I
it
want
showed them, but
you have
didn't
to
like
type
it all.
The right one because
So like,
I
who should
want all the
combine
customers.
a customer, in this case,
So
customers.
the rightness
So
and
you'll do
leftness
some,
is
right
not about the
so
order in the
all
join.
customers.
Oh, yeah.
It's
And then
about
where their
from
favorite
versus
products
the
would be,
join.
they didn't have
Remember how I
all
removed the
right,
white
so
space?
like,
Right.
where favorite product.
Now let's run this and see how much closer.
So you
We
can
won't be there,
combine
but
those two
we'll be
things
closer.
together to show like
Where?
which ones don't have it, and it'll get rid of the ones that
I'm gonna
do
give you
have
a
it
tip.
master, and only show
Let's
you the
say
ones
just
that
a
don't.
select star.
Yeah.
I want you to see more
He
things.
hadn't
so I
really
think it'll be
shown
obvious
that
to you.
particular thing, but
How
it's
you
like
break your
one
fingers.
piece was there and the other piece was there. You can combine.
So I got
them.
everybody.
You've
That's
got
the whole thing
everybody, and
about
what
all
do you,
these-
there should be a
all
pattern
the
that leads off the
selects and
screen
layers,
Right,
really
no.
about
easy.
some of
You
them.
can
Where-
make lots of things happen with
C
only a
dot.
few keywords that you've learned. It's like just
Favorite
by
ID.
mixing and matching those things. That's why we said you've seen like 90% of SQL, or
Favorite dot.
95% just
Favorite
yesterday,
ID.
because that's all there really is. It's just,
Is, no.
it's how you put it together.
Perfect.
Crushing it. All me.
That's good though. Those are good moments. There's a little pat on the back. You got it.
I don't know what I'm doing.
I led the horse to the water
Um,
and led her up.
Very
You got
good.
your tables, and you got your data in there.
Yeah.
Which one are you working on the?
So I'm doing the first one.
Okay,
All the
list
favorite
all
products.
favorite products for given customer ID. Okay. So you'll need at least one join, right? Because you're going to show the favorites
Mm.
for a particular customer.
Mm.
So select from favorites. So from. Let's do this. Let's
Select
break everything
from
out. So it's select and then from, and you to join on another line.
Okay.
Because it'll keep it nice and organized. All right, so now favorite ID isn't a table, but favorite is. So when you're doing from, remember from is like what table you want.
Table, oh, okay.
And joins are what table you want. So you got, all right, so from favorite, perfect. So now you want to join in, and you can call that whatever you want, yeah. And then now you want to join in, you don't need to write join in this particular one, you can just do a regular join. But you want to join in customers, right?
Yeah.
And you want to join in, wait, what was the, sorry, switch
second
back to the
one's
thing, I
easy,
forgot what the.
What's the
list
second
favorite.
one?
List products that have never been favorited.
Okay, so perfect.
It's like the same
Right.
but
I did that on purpose. It's the same task, but in the opposite order.
Right.
Favorite
Products.
Yeah.
nobody likes
So
cars.
join, customers.
Is that
there?
right? Did I do that?
the customer. Sorry, I'm used to saying plural on things. And then, all right, so next line, you can use, yeah, I'll start
Here we go.
saying, oh, join customers. It's like, oh, wait a minute, that's customer.
Yeah.
Yeah. All right, so do a new line because you're going to want to join in. Okay, yeah,
We
so
still have a
you can
minute
finish that
before
one.
we're
On
going
C
in.
customer
What's
ID
that?
equals F.
Do we have time?
F is going to have
Yeah.
a customer ID, right? Because that's the foreign key. So customer ID. So you're going to join it customer ID. That's right, and then F customer ID.
F customer.
Mm-hmm. So open up your tables while you're working, and it'll give you kind of like a roadmap to it.
Right.
If you expand these out right here, if you expand those out, you can see the columns, and open up the columns. Yep. And then kind of drag this down a little bit, and if you have each of those three tables open like that, that you're trying to get stuff from, it's like you can use it as a reference. Yeah.
Okay.
So open up favorites and products, and expand out those columns too. Yep, and then just open up the columns. Open the columns there. Yep, nice. All right. So now you can kind of see everything, right? So you can see favorite, that's where customers join in, and favorite is where products join in. So that's kind of the cross-reference table. That's the one that joins those two together. They join through that, right?
Okay.
So now go back to your query. All right, so now you're starting here, right? You're going to join in customer, right? This table on C customer, right? So that equals F customer, right?
Yeah.
Customer ID. You see how that works? Like you're joining those two tables
So it has
together
to be,
through that key.
It has to be in that order, like.
It doesn't. It doesn't. You could say join customer C on F customer ID equals C customer ID. It doesn't matter which way. You're just saying, get me join these two tables together where those fields match.
Okay.
It doesn't matter which way. And then you're going to join in product the exact same way, right? So you're going to do join products. And you can call it whatever you want. I mean, you can call that D instead of B. You know, it doesn't matter. It's just a nickname, you know.
Yeah. Then, all right.
So looking at product, what is the key? What's the foreign key to favorites? What's the foreign key there?
It's a product ID.
Product ID, exactly. So P product ID. Thinks you hit a key or something on that?
Yeah.
Huh. Oh, there you go. You got it. Okay, so what are you joining to? You're joining products to which table?
To customer.
Nope, that doesn't have a product ID in it.
Oh,
You're joining products
to
to
favorites.
the favorites, right? That's the one that joins them together.
Yeah.
And then that's got a product ID too, right?
Yeah.
So you're going to want to join product ID to favorites, product ID. And then, yep. You got it. All right, so go ahead and run that, right? Because you got the join, and now you see it's like, you see how you got the results from all three tables?
Yeah.
This is the results from favorites, then you got customers, then you got products, right? It's sort of like a wide representation of like all the select you're doing. Because you're doing select star and you're doing joins, it's like get me all the columns on that. And they're joined together. So now flip back to your yeah, all right, so list all favorite products for given customer ID. Okay. All right, so flip back, and how many customer ID? All right. So here's where you pick a customer ID, whichever one you want, whether it's one or two, and then you're going to add a where clause to filter that, right? To filter this thing. So your next thing is going to be a where clause. So jump down to another line in your query, and this is where you're going to do your where. This is where, oh. Okay. So this is where you're going to like filter it down, right? So where customer ID, because you're going to filter it by customer. And you're going to have to give it the alias, right? So you want to do like C customer ID, right? Like at the front, when you reference it, you do it at the front, like C dot. That's like the nickname you're kind of calling it.
Okay.
So you're saying a customer table, customer ID equals whatever, either one or two. It looks like you got two in there. Whichever one you want to pick. Yeah. All right. So now run that and see what you get. How many rows do you think is going to be in there?
There's only one row.
Just one, right? Exactly. You're like filtering it now. Perfect. Perfect. So that's it. So now if you wanted to just get the fields that you're talking about, like if you flip back to the assignment,
Yeah.
list all favorite products for a given customer ID. So if you
okay.
flip back, they'll say, so in your select, you want to say select customer ID and maybe like the first and last name and
Yeah.
then like the product name, right?
Okay.
So you just get those fields. So if you replace that star instead of select star, you say like select C dot customer ID. And you want to get rid of the star because you're kind of saying instead of all these things, I want to do just these ones.
That's
Yeah.
right, okay.
And then remember you do a comma in between those things at the top, in between the for the next field you want. Exactly.
Okay.
Exactly.
See customer.
So it's like which ones do you want? I want customer ID. I want C dot first name, C dot last name, and then for product you want P. So P dot product name, right? So you're picking just sort of just the things you want to see. And then from the product table, right? So you gotta use that alias. Yep, nice. And then product name. Yep. And then run that, and you'll see it kind of. Now you're just getting what you want. You see how that works?
Got it.
Got it.
Got it.
You got it. Now leave that one up. You can save that like as an example, and then each of those segments of the exercise,
Yeah.
do like a new tab.
Okay.
So you can kind of refer back to that. You know what I mean?
Okay. All right.
Yep.
Thank you.
You got it. Nice. Yeah. So you got it. Let me start. Did you get all the filters working? All the customer stuff working? You're like, that was me. Did you figure out the one where you want to show the customers that don't have a favorite product? Okay. Just a hint on that one. When you do that exercise, when you do that segment, you're going to want to use a right join. Remember where the example that Derek was showing, where you show customers that don't have a phone number, or that show me all customers, whether they have a phone number or not, and then it showed like nulls. When you do a right join, it showed the customer, but then like nulls for where the phone is. So if you think about it, you could filter where whatever is null, right? You could say only show me the ones where they don't have a phone number. So think about where is null in the where clause, and using a right join for that one. That'll just that's how for figuring that one out.
Is this like the first one?
First game was yesterday.
I don't know anything about it, but
I was about to do
Fired their
this all
manager
over
on
again.
Wednesday. Their first game is today.
Iceland played that.
No, but they play tomorrow at 9 o'clock in the morning.
I don't really like on soccer, but I just read something about them it's kind of crazy. Yeah.
Pretty wild.
Like they're I guess what preliminary game or whatever it is to like get them into the
Are you on the one where it says
World Cup? Yeah,
on
like
the,
a tenth of the country showed up.
Yeah.
It's
Okay.
fine.
So this, I'll give you a hint
Like
for
the
that,
fact that
because
America's done it, but
They got into like the semis of the freaking Euros 2 years ago.
I thought that was really cool. Yeah, they're crazy. I was in Ireland when they were doing so well.
Oh, really?
You've seen the beaches, but you haven't been there.
So that was intense.
But if you think about it this way, you remember the example.
They beat someone
4 years?
They beat England.
Did they?
They beat England in like the quarterfinals.
Cinderella story.
All the customers and all their phone numbers, but like one customer.
That was a good time because England is really they were pretty villainous at the like I kind of try to root for England sometimes, but they're pain. They're a real pain.
Is Ireland like very rivalry with England?
Yeah,
So I
Ireland.
can imagine everyone there was like, yeah, you know.
Yeah, everybody in Ireland hates England. When is Ireland playing? Is Ireland in this World Cup? I don't know. Why did I think they were? Well, shit. I really thought they were in the World Cup.
From is going to be like your tables. So your table name must be. So froms and joins are always going to be like, from the tables. So from table name, then you can give it like an alias there if you want to call it like an F or something, just space it out from favorite.
Go America.
So yeah, and then you're going to join that
Pretty fucking embarrassing.
to your other tables that you need.
Iceland's in it.
Product.
I know, that was like the big
So you
thing.
join product.
I forget what the ratio was like comparing the populations of Iceland and America. And it's like, like damn, they really pulled it out.
America likes to make decisions about the way that we play soccer that like actively nukes our ability to compete on.
Oh, really?
Yeah, like the college rules are like not
There's
soccer
like not-
rules. It's like a different because you can sub.
It's like the metric system. Like
You can-
we're never just gonna.
You can sub on the fly in NCAA soccer, and you
You want
can
to join your one.
you sub as many times as you want. Whereas in real soccer, you get 3 subs a game.
Right. So they're
So they go
accustomed
it's like
to
hockey. You just
go
when you're on the field, you go as hard as you can, and it's just
You don't have to be as conservative with your energy and players.
So like our players are not fit enough to play for 90 minutes, and then they go and try and play in the MLS, and the MLS has European rules, and we just suck. We just suck. It's the NCAA's fault. They need to. Well, also there's pay to play around here. There's basically no way to get into actually being good without having a lot of money.
Now do the same thing on customer. So you're going to join customer.
Like this is most likely to people make careers out of soccer, like paid to be in leagues for a long time, like before they got picked up by like like to do what do they call them, like travel leagues and stuff, like when they're younger and so they so you actually had to come up with some get that upbringing was decent.
Okay, and then
Like not the ability to actually
what's in the customer?
Yeah, exactly. Like in Europe, they have like
Primary key.
each club has a academy
So you already got
that has school for 4 hours and 4 hours a day. And then they'll come out and they'll track you down, and if you're good, then they'll bring you in.
Right.
There's not that. If you're good at soccer here, then you better have thousands of dollars a year to put into
So what's your fee?
put into paying for, frankly, subpar coaching
Right?
situations.
And then what's the field you're joining on? What's the column in the field you're joining on? You're joining customer. No, that's no customer ID, right? So if you're in the customer tables, yeah, customer ID. That's like the 1, 2, 3, the unique customer. And then here you've got customer ID. That kind of references back to that's the foreign key. So think of it like this: like you've got customers here, and you've got products here, right? And these aren't related, right? You don't see a product ID in that table, and you don't see a customer ID in that table, right? You got this table in between. It's favorites, and that's what links. That has a customer ID relationship, and that has a product ID relationship. And basically, you're saying every time a customer, like when you're on Amazon, you go and you're like, hey, I'm gonna favorite this, product or something like that. Okay. You're basically saying the customer is selecting that product and they're making this new record. which represents like a favorite. And that has the customer ID in it. And that has the product ID in it. And that's a representation of this customer has liked this product. And that's what joins them together like that. So what you're saying here is, I'm going to grab, give me all the favorites. I want to join in products, because I want to get product in. And I want to join in your customers too. So I'm going to get customer first name, last name, and I want to join these on the product. I want to join products on the product. Product ID equals all that. Product ID. And I want to join customer table, customer ID. Well, so that's what links all three of those together. You know what I mean? So there you want F dot customer ID.
I guess not every.
So now you have all those joined together. Now go ahead and hit execute, because that's a valid statement already. And you see how now you're getting the results from all your tables. They're all linked together on the IDs. Right? You can see the favorite customer ID, that matches that customer ID, that customer ID matches that. Yeah. Customer ID too. You see how the tables are all, it's like you instead of doing select, you're kind of smushing them together on those IDs. And now you have a big statement like that. And so now instead of select star, which is like give me everything, then you might want to say give me my customer ID. Yeah, it might be different. First name, give me my last name, give me my product. So replace that star with just those fields that you want. So you can say dot, and remember you gotta use the nicknames, right? So if you say customer ID, you say like C dot customer ID. And then if you wanted first name from customer table, and you do a comma between these, what would you do if you wanted the first name from the customer table? Yep. You got it. And then your last name, and then get the product name from the product table. Just like that. And then when you do that, you'll see that instead of this wide result set, you'll just have the data that you want. You'll have just the right string. And that's the first exercise. That's the first part of it is, then you want to do a where, and you want to filter it where, so this customer ID, then you want to filter it to only one of those, right? So you pick customer ID 1 or 2, and that's when you put your filter on there. So let me give you one. All right, so go ahead and add the where to the very bottom. So then this is where you're going to kind of filter this set down, because you don't want customer ID 1 or 2. Pick one. You want 1 or 2. Just be where, and then what's your customer name? With the alias that we want to see, right? So then where C dot customer ID, let's filter it based on that. And then equals, and then you pick either one of the filter. You just pick filter, but you got 2 customers now, and so you pick one of those. Alright, so how many, when you run that, how many rows do you think you have there? You should filter from our customer ID equals 1. Yeah, exactly. Go ahead and run it. Yeah. Yeah. Boom. And see how it shortened it down to that? Now add last name. Yep. So you get a customer table. So what you would want, last name, and then add product name from the product table.
Alice and Bob.
Product table.
Always for the word join.
You want the name of the product. And you can add ID to it too. You can add the other field. You
can't put it actually where.
Okay, so it has to go like because we've already. So well, I don't think we're because I don't think
all right, then run that. Nice. See how it's just what you want?
Just what
Yeah. And then you can save that query as like a reference of how to do a select and how to do a where. And you just go to file save, just like you would any normal file, you know, in any program. Just file save.
No one's
And you save that in your, like make a folder in your power thing. So you'll see or something like that. You can save those all.
You gotta bring the whole customer
examples.
table.
You know, to look at it later.
Yeah.
You gotta bring all the customers.
Yeah.
Right?
Yeah, and all the customers
Do I have to do that?
And then F, product ID. But we have product ID.
Okay, because we probably don't have
We're still in the section.
Yeah, I think.
Go down a little bit.
When you look at both the questions, the first one said for a given customer ID. And this is like a common table. This was the answer to the first one. And so for a given customer ID, the last thing is where customer ID. So the last statement, for a given product ID should be where. Yeah, that's the thing. So it looks like we've got everything right except the
Where? Yeah, it's gonna pull up. But it's only gonna pull up.
It's going to pull up all the customers who have paid with
Oh, okay. Alright.
Yeah, whenever you do right join,
Yeah,
you're
yeah,
saying right join. I usually do different. I usually do, I would join as like customer, and then I would do, left outer join. And it does it. Yeah, nice. Nice work, yeah. It's kind of like the null set, you know what I mean? You're sort of like figuring out things that don't happen. Oh, yeah, so the sequence goes select, and then from, and then journeys. Well, that works. So you just dump that little join line, and so you work here. Yup. And then remember, no semicolons, at least not yet. When we get to my sequence, we will, but not in the No, you can use your aliases just like that, but once you get an alias, it's always using table. So like, because favorite task customer, that when you hover over that, it'll say this is if you hover over that red thing right there, it's just ambiguous because it's like which table you're telling them about. Yep.
That's because he's the only one who's favorite.
Okay, so now in your select, you can you need to do one more join.
Nobody, because nobody's going to
do favorite. You don't need brackets there.
This I like three. It's gonna be challenging. I have to use the counts. At least one.
That'll work because first and last names only exist in the customers. But if they existed in another table, it'd be ambiguous. You have to use the aliases. In this case, it works just because it's not ambiguous. So now I do another join after join favorite, and I remember you guys what it's probably with. It's like it's always a list from all your joins and stuff, where, and then like by and order by. It all comes out of the Once you get used to that, like just in practice, you'll do like select from, you'll do all your joins, you'll do everywhere. It's like it'll So yeah, join in your products there. products or product table. You got it, just the product name, the table name. Whatever you want. You even nail it. And that, those areas you can pick it all. I mean, you can see whatever, it doesn't matter. So what are you going to join them on? Look at your product table over there. No, you want to join them on the key. They're never on the keys. So you're going to use, when you're joining a table, you're normally going to join this on the primary key in one table, the product ID, and then your favorites table, you're going to have a foreign key, right? This is all your favorites table. What would that be linked to? Right, exactly. Exactly. Yep. Think about products. What are you going to link that? What's the foreign key for products? Look in the favorites table. Look in the favorites table. What's the foreign key for products? Product ID. Well, not actually the same thing. Whatever the name is. Yes. Yeah. So I was going to say, normally, like in my databases, that would be ID. Yes. I use ID. For my permanent keys, I just use ID. Okay. So it's not always going to match. In this case, Derek did it the right way and made them match. So it makes it very easy to learn.
Now that's.
You're not always going to see that.
And I'm going to try to do that.
And then now that you've got products up in your select, list. Yes. So I do go ahead and add product name to the end of your products list. Very cool. Yeah, you got it. But it's going to look very similar. And then you can change that word. You basically just write a query that, like, you're going to log in. And I would pass you back using the query for like what your favorite product was. And it's only one query. Exactly. Now you're thinking. Yep. So if you remember, those query parameters, remember those AJAX calls? Remember the parameters that we were sending, within the data. All that would do is to change your ID every time. And you get back and it's like that little list in the corner. And it's like favorite products. You just sort that. So remember when we so call something like this, like call into a highway. You remember all those AJAX calls we were making, like the APIs for those examples? In the URL, there's usually like remember the things like equals and like Richmond or whatever the zone would have. That's like a query parameter. So on the web server side, it's going to take that query parameter, and that query parameter is usually going to become a parameter. So it's going to like use that. It's going to clean it up to make sure like you're giving it like crazy input. It's going to like sanitize it, and then it's going to use that in the query it looks up in the database to send you data. Yep. Sounds good.
I think that one might be sending you messages about resuming
Okay.
earlier than now.
Okay. Yep.
But I just got a duplicate question, so I think I know what I want to talk about.
All right. Are you streaming?
Let me double check. Yeah, I never stopped it.
Okay. Go ahead and, if you don't mind, like just
Do a toggle.
Just leave it going for now, actually. Yeah.
What your real message is, Derek, please remember next time during exercises to stop it. I'll try.
Yeah. I'll try to remind you.
You told me yesterday, but I forgot.
Yeah.
I was so eager to jump out and talk to people. They're ready?
Yeah.
Okay. Sure, I'm on camera. We're all good. I am a bit dark in there, but that's fine. All right. So I walked around and talked to people. Obviously, it was an exercise with lots of steps. The point was just to sort of challenge, and it also gives me an opportunity to get out there and feel where the pros and cons are. So what I'm going to do is I'm going to give my answers. So I'm going to pretend, once again, like I did that one time yesterday, that I was given the exercise. I'm going to walk through it and then explain how I'm going about it, not just the correct answer. A number of these, by the way, the more advanced we get further in the course, there is not just one way to answer these questions. T-SQL is a powerful language. I saw a couple creative solutions out there as I was walking around that actually do work correctly and are not identical to what I did. So I want to just point out that if you run it, if you give it the correct parameters and you get this correct data back, then you did write it in one of a set of correct ways. There's not just one right way to do it. I, of course, am biased to my own experiences, so I will write the way I think would be the best way, but it's not the only way. So some of you did a good job.
Just before you get started, there's been another request to kind of like put yourself in the bottom corner. Just
Bottom
or
corner?
Maybe make the
All right,
thing
I'll
smaller.
keep it there.
Just make it a little bit smaller.
Smaller as well?
Yeah. They say you look like a shadow anyway.
They don't
so
want
it's
to.
hard
They don't
to
see
see.
me. Wow, I go all the way down.
Yeah,
now.
there you go. Just make it small. That'll work.
This is just proof that I'm probably alive, unless I'm some robot or something, some AI. Okay, so I'm just going to go through these. The first exercise was actually the one I already did in front of you, but I am going to redo it because it won't take me very long, and I get the feeling a little bit of review is not going to be harmful. So I'm going to refresh the data. This was the data as I actually sent it out, so this matches the data file that I sent out with the tables. Let's just remember, let's recoup where we are. Bob has two favorites, the car and the camera. Alice has one favorite, the camera. Charlie has no favorites, and the laptop has never been favorited. Right? This is a nice small data set, but covers actually a lot of permutations that we want to query on for this set of exercises. So let's open a new query window. If you've already written this, you can just watch and compare. If you got a little bit behind, as I catch up with you, you can resume following along. So let's redo that first one. List all favorite products for a given customer ID. First thing I want you to do is just analyze the English of that exercise. It has the word favorite, products for customer ID. Well, favorite is the very first word there. So which table are we probably going to start this query off with? Favorite, obviously. We cannot get any information about favoriting from any other table but favorite. So let's put it on there. My style, once again, is to immediately press F5 and see where I am in the world. So I don't get lost in this morass of all these new techniques I'm trying to use. For a given customer ID, well, if we look, I've already pressed F5, and if you look, there is already a customer ID column, which means I don't even need to bring in the customers table, right? I have the ID right there. So let's go ahead and filter this down. So whenever we have a large data set, we need to filter it down by some criteria. What do we use? Where? Very good. Or f.customerID, because that's what we're filtering on. Remember, it's list all favorites for customer ID. And I'll pick Bob because his is the most interesting set. I'm immediately press F5, and what you're going to see, 3 rows, which has customer IDs 1, 1, and 2, become 2 rows, just number 1. So we've already filtered down the data from a large table, let's pretend it was big, had lots of rows in it, to just the 2 rows for him. Now, technically, if all we needed was product ID, we could actually be finished with this task a little bit prematurely, but we could change that select star to f.productID, products 1 and 3. But in most cases, that's not sufficient. The primary key is needed, it's going to be important, but let's pretend that the app developer actually wants the name of the product too. Well, the name of that product is not, I'll go back to star for just a moment just to show you, is not in this data set. We have not accessed enough data to know the product name. Where's the product name stored? Product table, right? What's the keyword we use to bring in other tables? Join. We're going to join to that table. So we know we have to type it. Please join product. We always have to do an on. And which column do we pick? I heard a guess for product name. Not correct. Close though. the ID. So here's a tip I want to give you. When you're ever not sure in a well-designed database, like the one I have for you here, if you're ever not sure which columns to join on, ask yourself the question, what column is shared between the tables? And how do you figure that out? Well, let's open it up. Let's open up the favorites columns, get that on our screen. Let's open up the product table and look at its columns. What column is the same in both? Product ID. That's the correct answer. So we just do f.product ID, and we're always going to do equality in all of our joins for this whole course. That's the easy, simple way to do it. Equals product ID. We now have a successful join. Let's press F5 and see where we are. The quantity of rows is still correct. It's still limited by customer ID number 1, and it has product names on it. We actually get to see them now. We see car and camera on the screen. That's good. We could be finished now, but select star is generally frowned upon. You'll see that I use select star until the end of an exercise. So the end of creating this query. I save the select for last. And one of the things I told one of the members here, just as a point of trivia, the way SQL kind of gets executed or interpreted effectively is it starts with the from, it then goes to the join. If I had a group by, it would do the group by. It would then do the where, it would then do the order by, then it goes to the select. So it's really kind of weird. I don't like it, but it'll never change. Select is at the top, but it's actually the last thing that happens. So when I'm writing it, it's the last thing I fix. It's the last thing I clean up. So select star gets too much data out. What data do we want? Well, if we look back at what we need, list all favorite products for a given customer ID, we probably just want product information. Well, I've already told you today that let's always bring back the primary key, so let's do p.product ID. We can go ahead and press F5. That's correct, but incomplete. Let's throw in p.product name. And there we go. So let's review what we wanted. List all favorite products for a given customer ID. This is the 2 products that Bob has favorited. Customer ID number 1. This is the end of that first query. And if you want to play and confirm that there's no smoke and mirrors here, go ahead and change that to number 2. Remember, that's Alice. I happen to remember that she, per our original data, which I'll switch over to, she also favorited the camera, although not the car. If you notice in the bottom, she's number 2, right here at the bottom. Let me highlight it. She favorited that camera. So if we go back to the query we were just working on, I've changed it to 2. There's her camera. And just for completeness, I'll go ahead and put Charlie's ID. Remember, Charlie has favorited nothing. No data comes back. It's got the correct columns in it, but there's no rows. So by just a couple little spot checks, I put it back to Bob real quick. This query's done, and it's working. We've tested it a couple times, and we're confident that it's working. So that's the one I'd actually already done in front of you, so that's a bit of a review. But also wanted to add to it by saying how I made the decision. The tip on asking when you do joins, what is the shared column name? I wanted to make sure everybody got a chance to hear that. Okay, any questions about that one? You'd actually already seen that one before. All right, let's move on to the second one. I'm going to do a brand new query window. I'm going to bring the data back on the screen. I like looking at the data as it is when I'm trying to figure something out. List all customers that have favorited a given product ID. Well, if you think about it, the query we just wrote, it's kind of the same query, but reversed. That is to say, what's coming in and what's coming out. It's going to be a very similar query. So this is the one that we just wrote. I'm going to write the other one, the new one, from scratch. But I want you to realize it's going to be a parallel. So if your brain starts connecting some dots there, that's going to be good, because they're actually mirror images of each other. Both of these are given a single parent ID on one side or the other. Give me the other parents on the other side of the many-to-many table. So let's write that one. I'm going to do that one from scratch. List all customers that have favorited a given product ID. So we're talking about favorites, so guess which table we got to have in there? Favorites, of course. We can't get away from that table when we're talking about favorites. Remember, it is the only table that has favoriting information, so it will always be present. So let's start with that one. That same 3 record set, okay. that have favorited a given product ID. So we're going to be told a single product ID. How do we filter down a record set? Where? You're noticing a pattern already. I'm basically asking the same questions because it's a very similar task actually. So where product ID equals, and I'm going to pick the more interesting one, which I happen to know is the camera. So I press F5, and before I press F5, you'll notice the product IDs are 133, 133. Press F5, we're down to just the favorite products. So we're already getting close. But it does say list all customers, and let's say we ask the app developer, do you want the customer name? And she says yes. Okay, well, she wants the name. We're going to have to bring in another table which has the information that we want. We want customer information. Which table we're going to bring in? Of course, we're going to bring in customer. How do I know which column to join on? The one that they share, customer ID. I'm hearing everyone say the right answer, so good job to many people. I do want to re-emphasize, the order in which you type this join predicate does not matter. My personal style is I match the... My preference is to go in the same order I've declared them in the query. So because I did favorite first and then customer, favorite's on the left, customer is technically on the right, I form them that way, but I want to tell you that it's not important, and some teams are actually pretty strict about that. You just have to fall in line with whatever that team does. But this is my style. It gets the job done. So we bring in customer. I'm going to go ahead and press F5. Once again, we have the correct favorite records, the correct quantity. We have the names we want. But if you look at this, there's a lot of noise on the screen. And that select star doesn't really perform very well. That is to say, it pulls back too much information. It's kind of noisy, is what we call it. So let's increase its signal to noise ratio by pulling back only the columns we want. So list all customers that have favorited this product ID. We definitely want the primary key every time. Just always put it in there. And let's just pick the first name just to be quick about it. Bob and Alice. So Bob and Alice have favorited the camera. Well, that's correct. Let's play with the query. We can change the product ID to number 1, which is the car. We should see Bob. Perfect. And let's change to, I've even forgotten what it was. Was it a laptop? Yeah. We'll change the laptop, which is number 2. We get no records back. So I've even played with the product ID multiple times and pressed F5. I'm back to the camera right now. I know I'm doing that kind of quick, but these are just spot checks. This is how I make sure manually I'll do a couple quick runs in my query to make sure I've typed it correctly. Sometimes you don't know, right? It's very possible for the record set to be empty, not because there's no matching criteria, but because I've made a mistake. So I'll run through a few spot checks. But this is the end of that second query. List all customers for a given product ID. Here's the product. We're talking about favorites, and we have all the pretty customer information, which is their first name and their ID. So if you look at that query and the one we had just written, I'm going to go back and forth quickly. I'm going to toggle back and forth deliberately quick. And if you notice, the from is identical. It's swapping out product and customer as I go back and forth, but I'm doing this to sort of show you the pattern. We just brought the other parent in, and the where clause has the thing that's the input, and on the select we still have 2 columns, but it's the other parent. So both of these are actually the same exercise from 2 points of view, which is why the queries are so familiar when you look at one and the other. That's why I keep going back and forth. There's more. I wanted to show that as a pattern. They're very similar. It's just which parent is the input and which columns are the output. So those two exercises are basically the same exercises. Any question about this one that we just completed? Yes, in the back?
So what if you wanted to include the product name so if it's in a different table? Can you like join multiple, like 3 tables together?
Gotcha. So the question is, do we want to have the product name, and the follow-up part of the question is, can we join multiple tables together? Well, the best way to answer the question is to try it, and let's do it right now. So let's join product P on, and once again we have to decide, where's the product ID going to be? Well, because the way I'm designing these databases, I get to follow that same rule. What is the column that's in both the product table and the favorite table? There we go. Now I'm going to add the asterisk back on so we can do a little quick test. Yep, I've got camera on there twice. That looks pretty good. So the answer is yes, we can definitely do the join. I'll change that star to p.product name. And this is what the outcome would be. So the answer to your question is absolutely. You can do that join, it works. And yes, you can join multiple tables. There is effectively no limit to the number of tables. I'm sure there's a technical limit, but I've never reached it. And I've worked on some really big queries that join dozens of tables. They're a little bit tough to type and get right the first time, but they do work. So this does work. If the app developer wanted that, there you go. You could return that. You're bringing up a good point, though, because if you look at the screen, there is something a little bit weird here. We know we're pulling back precisely one product ID because that's what's in this where clause, which means this column would always be duplicated. So in general, I'm usually not going to write a query this way because it pulls back the same data over and over. It's pulled back camera twice, and it's giving it to the app twice. And that app is streaming data across the network. I'm streaming the word camera maybe 1,000,000 times. So in general, I probably wouldn't do this join. It's totally possible. There's nothing illegal about it. There's not even anything technically really bad. It doesn't perform worse or anything like that as far as the database is concerned. But this should strike you as weird that it's on there twice. So as a fake follow-up question that I'll make up, Derek, what would you do in this case if you really wanted it back? What I would do is not do the join. And if for some reason the developer wanted it, it's actually possible to write on this screen and invoke from an app and return 2 different record sets, just like I've been doing since yesterday. So what I would actually do if the person really wanted that is I would actually run 2 different queries on that request. I would use the same number. I'm always going to pull back the primary key and the name. So I would actually run this for them. That way they get the original requirement, list all customers that have favorited given product ID, and an extra data set that contains precisely 1 row that contains all the information they want about the product. And it's possible not only to press F5 and see this in SSMS, but you can from an application pull back multiple record sets. You'll notice that camera appears on the screen only once. I personally like how lightweight that is, right? Because that camera could have been favorited 1,000,000 times, but I would only pull that across once. So it's totally, the answer to your question is yes, absolutely. I'm usually not going to do it though. I would prefer something like this. Good question though, really good, because it actually leads into something I'll be talking about in a few minutes, which is the multiple record set.
If you already know about product ID 3, you've already got the camera, the ID in the camera in your application normally.
Yes. So Harper just commented, and I'll repeat for Winston, exactly correct. Usually if somebody delivers you a primary key as a filter, they already know a lot about that. They probably already had the name earlier somewhere else in the workflow. So often not even what I have on the screen is necessary. But it could be. They might have ran something that pulled a product ID and had no other data. And now they're asking this list all customers question, and by the way, please tell me more. And this is totally legitimate. I do this in products all the time. I will return multiple record sets when that's the most efficient thing to do. It's a good point though. Usually you don't need to. For some other reason, it's already taken care of. That's good. Question on this one or its altered version? Anything? That one's not too bad. Let's move on to the ones that get a little bit more tricky. And they were tricky on purpose. Let's see, what's the next one? List all customers that have at least 1 favorite product. All right, that's not as tricky as I thought. So this is one of those that has multiple ways we can solve it. I'm just going to pick one way to do it. We are talking about favorites. So it says list all customers. I'm going to start with customer. I've been starting with favorites before, but I'm allowed to start with any table I feel like. Let's start with customer. There are 3 customers. It has at least 1 favorite product, so I must talk to the favorite table. How do I bring that in? Join, exactly. Let's bring favorite table back into this new query. How do I know which column to choose? the one that matches. And if we look on the left, if I look in favorite, customer and customer are the columns. So it's got to be customer ID. There we go. And I've actually, the join has let me already accomplish part of the goal here. Because it explicitly says, has at least one favorite product, I'm going to rerun this for just customers to remind you that there are 3 of them, Alice, Bob, and Charlie. When I run this whole query, somebody's missing. Who's missing? Charlie. Because Charlie has no favorites, he's already gone. We've already eliminated him from the record set. He got excluded, poor guy. We're down to just the set of favorites that have been favorited by, where the person has at least one favorite. So the fact that Charlie's already gone should key you in when I say list all customers that have at least one favorite. We've already thrown out the ones that have 0. So we're already at least one. Now it's still not written completely. There's a lot of noise on the screen, but we've actually already done the elimination process. So we've kind of cheated. The inner join can allow you to throw records out you don't need anymore. And for this, that's actually going to be exactly what we want. But it is too much data. For one thing, it says list all customers. There's a whole lot of favoriting information on here. And if you look, Bob is on there twice. And it didn't say list all customers many times. It just said list all customers. It's pretty rare that the app wants duplicate records for the customer. So let's trim this down. Let's trim this down to just the customer information that we know we're going to want. We always want the primary key. I'm going to pull back first name and last name just because I feel like it. And I'll press F5. So we're still good, right? Charlie's been excluded forever. I can see people are following along. I've gotten to the point where I think I'm on board where people might have left off. So we're down to Charlie being left out. We have 2 Bobs and Alice. So we're close, right? These are the 2 people who have at least one favorite, but there's clearly a problem. What's the problem? Bob's on there twice. We don't want to see Bob twice because that's not what it says. That's not the spec. So how do we eliminate duplicates?
It's like a distinct way or something
Distinct.
like that?
We got the word distinct. And you can actually cheat right here and put it right in the select. Sorry, my computer froze a little bit. Press F5, and we're actually done already. We've actually completed that exercise. What's cool about this exercise is the inner join actually accomplished something that you might have felt was tough, which is how do we get rid of Charlie? How do we get him off the screen? Well, because the nature of the request is has at least one favorite product. He has 0. He got excluded in that very first join. So then all we had to do was the fact that we had duplicates. So I had to, I did trim it down to just the customer information. If I did the distinct before trimming it down, I would have still had the duplicate. I needed to get it down to just the customer information, which is what our specification required of us. And then I applied that distinct keyword right at the end, and we were magically finished. Question?
We've got a request.
Okay.
It said, could you show us how to do this if the number was greater than 1? Like if they had more than one favorite product.
Yes. I'd like to save that to the end
Okay.
of this particular block, but yes. Don't let me forget, though, that that's wanted.
Okay.
Because I'm following a list here. I want to do the other joined ones first. That's a good question, though. It's a good one. We'll come back to it. So on this one, where I've actually accomplished the goal, list all customers that have at least one favorite product, any question here? You'll notice I've brought in a technique we learned yesterday, that distinct keyword. I showed you that, but I wanted to show you that these words will keep coming up. Some of these functions will keep coming back to you. You'll have different combinations. That's all you're really doing with T-SQL or ANSI SQL. You're taking a few things you're going to learn. What's a from? What's a join? What's a group by? What's a where? What's a select? What are these built-in functions? You're just sort of assembling new puzzles every time. As was mentioned yesterday at the end, Harper mentioned this. Once we talk about all these ways to do these basic queries, you'll have 80% of the knowledge that you need. Now, it might take you 5 years to finish in that last, 19.5% as you approach. There's diminishing returns on how much there is to learn, but most of my work in T-SQL is a high quantity of just reassembling all of these techniques. So although there's a cool long path as a DBA, there's some repetition. I've been typing select statements for many years. And it's really just reassembling them in different ways. So I brought in distinct, and that one's been solved. Let's move on. List all customers that have no favorite products. Let's open up a new query window. Actually, let me close out of some of these and let's review the data. The raw data as it is. So list all customers that have no favorite products. Well, looking at the data, you can probably guess who we should see if we're successful. Charlie. So we already know as we're writing this query, if we keep on seeing Bob and Alice show up, we're not writing it correctly. But if we get it down to just Charlie, we're probably going to be good. So list all customers that have no favorite products. Well, let's start with list all customers. Well, let's actually type that. How do we list all customers? We select all of them. And I press F5. Or there they all are, in all their beauty, but we're not finished yet. That have no favorite products. What keyword do we use when we bring in another table? Join. All right. And obviously it's going to be the favorite table because that's what we're going to do. Oops. And I know what column they share. I've typed this enough now. It's always going to be the same join predicate. And I'll go ahead and press F5. And what do you think when you see this record set? You know what you're expecting to see, what we want to see if we're successful. Compare that to what we do see, and how do you feel? It's the, yeah, person in the back said it. It's the exact opposite of what we want. So something, we're 180 degrees off our course that we want to go. We're heading north, we want to head south. But what that means is we're actually closer to our goal than you might think. So I showed earlier when I talked about phone numbers, remember that I actually answered the question, who does not have a phone number? How did I do that? What keyword did I bring into this? It was one word.
You did a right join on that, but in this case you need to do a left join because you're grabbing from the other direction.
That could not be more correct. That's about as correct as you could possibly be. What I did last time was I pulled in a right join. Right join is where I want everything from the right table if this were lined up horizontally on the screen, like so. But in this case, I want left, and I want to do a left join because I want, as the specification says, list all customers that have no favorites. So we definitely want the all customer attitudes. Let's turn this into a left join and press F5. Now we've brought Charlie back. We still have Alice and Bob in the way, but something should leap off the screen here. What makes Charlie look special?
No.
Null. So how can we select out one row from a set? Where? We can use a where clause. Well, what can we do with nulls? What kind of where can we type? Where is null? Very good. So let's do this. Where, and I can actually pick any of these columns I want. It doesn't actually matter. I'll just decide to pick favorite ID just because that's what I feel like doing. Remember, I cannot do equals null. It's got to be is null. There's no such thing as equals null in T-SQL. Don't ever type equals null or not equal null. It's got to be is null or not.
I'm wondering if favorite ID, by picking that one, since it is the primary key, that wouldn't be like a little bit more efficient maybe, because you're checking nullability on the primary key versus another one.
I actually don't know technically if that's correct. You can tell me if you think it is.
Yeah.
That is why I pick it.
Yeah.
Because I mean, it's either correct or it feels good.
Yeah, it just feels, it feels right.
Feels
Yeah,
right.
It might,
Just feels right.
It might be more efficient. I don't know.
Yeah. So.
It is on the clustered index. You're checking a value on the clustered
Right,
index versus
which is
something
always
else.
going to be the fastest.
Yeah.
So Harper's commenting about my choice here on the column is this actually going to execute faster? I don't know if it does, but if it's possible for any of these to work faster, that one will be the one because it's a clustering key. It's that primary key. Question?
Well, wouldn't it make sense to do it by that one because the question says we're looking for the ones with no favorites?
I like that answer too. I mean, this is what I personally do, but I actually don't know the academics of which is technically better. All of them do function, but I definitely pick the primary key. I would suggest you do the same for the reason Harper just mentioned. If it's possible for the optimizer, which is the thing that interprets your query and runs it against the database data, If it's possible for it to care, this is the choice it would always want you to make. Those primary keys will always be the fastest lookup you can do against the actual data in the table, which includes checking nullability on it. That's a fine sort of filtering. So let's press F5. Now remember, I asked you at the beginning of this particular portion of the exercise, what would we expect to see if we were on the right path? We would see Charlie all alone. Well, we're really close. So we've got Charlie all alone in his own record set. List all customers, no favorite products. It is kind of noisy though, right? We've got a bunch of garbage in this data. So we come back at the very end and let's trim it down to customer ID, and I'll just do first name. There's Charlie all alone. And he's all alone not because we put a where clause that filters out IDs 1 and 2, but we arranged a query that only grabs customers who have no favorites per the left join. And we use this is null to guarantee that.
And
Yes.
You mentioned kind of like the creative solutions to this. You could also start with favorites and do a right join on customer and kind of accomplish the same thing.
Yes, Harper said, could I have started with favorites and had customer as the join and turned it into a right join? That's identical outcome. The two are identical. So if you reverse those and use the word right, you still did it absolutely correctly and your query is correct. Question?
So when you declare like a left join or a right join, just to be clear, if you do left, it's always going to select whatever's in the from.
Yes.
And if you do right, it's whatever's on the join.
Well, it's whatever's left of, because if you're putting a ton of joins together, if you're joining lots of tables, and then you do a left join down here, it's going to be all of this stuff, like what you've kind of previously joined. So think of the left and right, not so much on from and the rest of it, but wherever you have that join. So if you have 10 joins, you have your left join here, it's going to be like left and right of that whole section.
But it's literally where the join is.
Yes.
Okay.
Yes.
Yeah, physically in the query.
Yeah.
So
Okay.
Harper was talking about the arrangement, and I'll sort of restate it in my own terms. And I've moved this code like I did at the end of yesterday. If you actually look at it, now that I've removed the white space, customer is literally to the left of the word join on the screen. It's literally that direction. It's earlier in the query. And I am saying, whenever you say left or right, you're saying that's the one I want all of them from.
Yeah.
That's the one. So in this case, just like the paper says here, list all customers that have no favorite products. I have this saying from customer left, meaning pick all customers and then throw on favorites whenever you can. It's sort of a casual statement. But in this case, Charlie has no favorites, so he gets picked even though there's nothing in the favorites table. And then we nuke all of the, we only pick the ones that are null, which means we're throwing out Alice and Bob, because they actually did have matches. Remember, before I had the where, we had the full set here. Bob, Bob, Alice, Charlie. I don't have a select star anymore, but then when I throw out all the ones that don't have a favorite, so favorite is null, I'm left with Charlie, which is exactly what we wanted. Yeah, it's all about, the left-rightedness is really physically where it is in the query. And left, we write these vertically because this is hard to read. That's the same query.
Right. I'm just trying to map tricks.
Yeah, oh, absolutely. That's what the human brain does, and it's very good at it, and that's a very good technique. Although I'm listing this vertically, it is all about left is earlier in the query, and right's later. Right's the one over here.
This is a super powerful concept. I mean, you'll use this a lot.
Yeah.
Where you're trying to find things that don't have a match.
Yeah. Because if you think about it, it's a relational database. We've been talking about relationships for 2 days, and that's all you're going to talk about, one-to-manys and how they relate, and how child records relate to parent records, and many-to-many relationships. As with any relationship check you might have in life, sometimes the question is there no relationship? If you ask somebody if they're single, you're saying, that's a left join question. if there's no one on the other side, then there you go. So relationships are both positive questions and negative questions. Or is there no relationship there? And in this case, Charlie has no favorites. He has no relationship to that product table through the favorites table. Any question on that one?
What does it do if you just like push join on? Does it like just anything around it joins?
I think the question is without the word left. So if you put no qualifier on join, there's actually an invisible qualifier. We call that an inner join. An inner join, which I have showed a few times, the plain old simple join, as I've typed it here, is on a Venn diagram the parts that match. We had to do the left because we're actually wanting non-matches. So inner joins are all about there is a match. Left join is, it keeps the matches too. So a left join in a Venn diagram is both the middle and the left side colored. So you're getting both of those things in there. But once we put on the is null, we throw out the matches. So it ends up being super left only the outer circle and not the matches. And that gives us only Charlie. Any other questions on this one? If it's still a little bit fuzzy, don't be too worried. The next exercise is the inverse of this, so we'll be doing it all again. The no favorite products. So the very last one, if you read it, it's kind of similar. The English is a little different. List all products that have not been favorited by anyone. So once again, I deliberately did this. We have an exercise query, which is if you get the one I just now typed, the other one is just the inverse of it. It'll end up looking very similar. So let's revisit the data. Let's not forget where we are. I'm gonna keep that one on the screen. I might want it. So list all products that have never been favorited. Another way to word this, list all products that have no relationships through the favorite table. This is actually going to be the same exercise. I'm showing you the data to ask you the question, if we're on the right path, what should we see? Laptop. Laptop is the only product that has no records in the favorite table. This favorite table never has in the product column a 2. The number 2 is not there, and 2 is the number of laptop in that product table. So if we're doing this well, we'll end up with a laptop. But let's see if we can write it. So it is list all products. So let me just start with that. From product. There all of them are. Well, that's obviously not enough. We need to constrain them by not being favorited. Which table do we need to involve? Favorites. People are going to start being bored if we keep asking the same questions over and over. Favorite.product ID. So I press F5. I've still got all of them, and I've involved the correct table. Well, I don't have all of them, do I? Something has already disappeared. Something already disappeared, and somebody's already shouted out left. So in this case, the product table, and I will remove the white space for a moment, is on the left side of that join. And which table do we want everything from to do the comparison? Left side is product, so I'm going to type left. I am going to move it to a new line now that I've shown the physical layout. So I press F5. Aha! We're back up to 4 records, or we've increased it by 1 to the number 4. And which one of those rows sticks out to you? The nulls stick out. And which product did they apply to?
Laptop.
The laptop. We're already on the right path, right? We already have a data set which looks close to what we're looking for. So how can we get rid of everything other than the laptop?
Where favorite ID is null.
Where favorite ID is null, right on the money. We're down to the correct data. It's got a little bit of noise in it. So let's go back as a very last step to the select statement. I'll do product ID and product name. And I'll press F5. We were hoping to see a laptop all by itself, and that's exactly what we have. I'm going to toggle back and forth once again to sort of show you the similarity in these queries. Their left join, the table part's identical. The join predicate changes, but only because the column that we're joining on changes because we're on a different parent. You'll notice the where clause is character perfect and identical. Once again, it's just we're doing the same exercise from a different point of view. These are very similar queries. They're worded a little bit differently on the paper, but from a developer's point of view, they are the same amount of effort to type. They're the same issue for the same reasons, and we type them in a way that's very similar if you compare the code. What was that question I was asked that I told you not to let me forget?
Oh.
More than one?
Yeah, so like, on the inner join automatically takes out all those with 0.
Yeah.
Is there a way to, show only ones that have greater than 1? And I said that was going to be a little bit more sophisticated query, because
Right.
you're going to have to, do a count and sort of keep where count greater.
I
than
like
1.
this though, because I'll be able to introduce the having keyword,
Yeah.
which I have not showed yet. I'm going to try to, let me think a second. I actually want to give a,
Do it a couple different ways.
I want a simpler version, and then I want to end with that one. I want a simpler version that requires the same technique.
Yeah. So the simple version is just like a
favorite.
It's like a complex query, a query within a query.
No, I'm going to do something simpler, and then I'll work up to that.
Okay.
Let's pretend that the task, I'm making this up on the fly, so if I start to make mistakes and look like a fool, just don't laugh too hard. So let's pretend that the spec is, given that favorites table, that's what we have, just list all the product IDs that have been favorited greater than 1 time, so 2 or more times. Let's say there's a magical number, our boss has decided that things that are favorited once don't matter. But if a product's favorited at least twice, by 2 different customers, then it's important enough to put on some maybe rebate list or something of that nature. Well, it's all about favorites. So guess what table we got to start with? There we go. Click star from favorite. There's our stuff. And here's some good news. I do have one product that has been favorited twice. That was the camera, I believe. The car was only favorited once, so we're probably not going to give a rebate on that car. So what are we going to do? We've been in this situation before. We've been in a situation where we needed to somehow talk about subsets within this set of data. What keyword did we use? What mechanism to talk about group by? That's right. We talk about groups within a set, because this set, if we look at it through the blinders of product ID, has 2 groups in it. It would have a group of product ID for 3 and a group for product ID 1. So we know we need a group by, and per the specification I made up off the top of my head there, it's all about product IDs. So let's go ahead and pick product ID. And I'm going to go ahead and put that in the select and press F5 here. So here are the groups, 3 and 1. But it's all about how many times it was favorited. What function do we use? Count. I didn't even know how to end that sentence without saying the word count. How do we arrive at the quantity of? Yes, count. Count is the right word. That one's a pretty good word choice. If you do count star, we're already on our way. Let's give it an alias just because it makes it easier. Quantity of customer. I'm gonna make it long. That favorited, just because I can, right? Favorited. Now it looks good. It's kind of long, but it looks okay. So we have the right ones, but remember the spec is that have a quantity of 2 or greater. So this record set is still wrong. We're not finished with it, right? Because we have product ID number 1, which is the car, product ID number 3, which is the camera, but it's got 1 too many rows in it. Now you might be tempted here to use the where. So I'm not going to tease you. I'm not going to quiz you. You use where to filter out the data being processed, but when you're doing a group by, there's a different mechanism we use, which is very similar to where, and it's when you need to answer a question, just apply a predicate, is a more technical answer, for a group, like when you're asking about a set of rows, which is a subset in the original from the original table. And that keyword, I'm just going to tell you, is having. Think of having as a synonym for where that you use for group by. So its purpose is the same. Its purpose is to filter down a set, but it's filtering down after the grouping occurs. The where is on the original data set. You can throw out some data if you want, or select some data, or meet some criteria. But after you do a group by, this is a follow-up sort of where. So we could say having. We can do count star, because remember, if you look at the record set, we already have a number 1 and 2. So we want to keep the 1s. We can say where count star is greater than 1.
Can you use the alias there? I'm just curious. I don't know the answer, but can you use your alias you gave there?
No.
Okay.
Because remember, the select is evaluated last.
Okay.
That sucks. I've always wanted that. I don't think you can use the alias.
Okay.
From what I can gather looking at query plans, this does not perform any worse. It's as if this occurs at the right time and it caches it.
Okay.
So I think there's no penalty to how I've typed it. I've never found a better way. So I'm basically saying, it's basically like saying where count is greater than 1, but it's a having because it's evaluated per group. Remember what we have on the screen here is not the original record set. It's a pseudo record set, a fake one, which is the result of after processing the group by. So if I press F5 right now, aha, we're seeing what we expected to see, right? I'm not pulling in any other tables right now because I want to show you the having without groups. That's why I wanted a simpler example. But if we just wanted to have a result of the products, the product IDs, only their IDs, that have at least 2, which is greater than 1, favorites from customers, this is actually that query. This is part of the way to, this is pretty much the answer. It's a shortcut to it.
When did having come available? Is that
I think that's old school.
2012 at least, or 20?
I think it's ANSI SQL, isn't it?
Okay.
I think it's ANSI.
Okay.
I think it's old school. I don't think it's a T-SQL feature.
Okay.
Yeah, having is the where, but it's after group by processing. Because if you think about it, I couldn't say where count here because the group by hasn't occurred yet. Remember, this roughly executes top from bottom except for the select statement. So I had to put it afterwards. I have to wait for it to group it and then count the quantity of matches within the group. So having and where are almost the same feature, they just occur at different points in the processing of the query. That's a pretty good question. So we can obviously improve this. I'll throw on the product table. We know what column they share. And let's say I want the product name, just to improve this some. Now if I press F5, it should complain. And I'm doing this on purpose to remind you because you will experience this a lot in life. Blah, 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 not contained in the aggregate. Oh, that's right. You always have to make the non-aggregate functions match in the group by. And you can see my technique is to copy and paste. I don't actually waste my time retyping it. It's always got to be identical, so I just copy and paste. Usually copy and pasting is bad in software. In this case, it's good. Now if I run it, I'm good. Now I can return back to the application developer the product ID, the product name, which is camera. That is what we expected to see. Remember, camera's been favorited twice. And I'm even sending them back the quantity it was favorited. Because it could have been favorited 1,000 times, and they might want that. I've already got the data. I've already done the count star. They probably want that number, so I'll just send it back. But if they didn't want the number, I could take it out of the select. I'll do that with a comment real quick. I could still tell them cameras. Cameras are well liked. I think that sufficiently answers that one. Yeah. People put me on the spot. Didn't practice that one. Actually, it's a good time to bring in the having because we had just talked about group by, and having's a good technique to understand. I use it sometimes. It's not too common. Wheres are very common. You're going to be filtering down with where all the time. Having is a lot less common, but it's in there.
That's the most common case of it.
Yeah, this is the most common case.
Is it greater than this row count?
It's some sort of frequency match or something like that. In this case, it's a frequency match. The frequency is greater than 1. And this could have been anything. Your boss might come in and say, anything that is at least 10 times, I can do greater than equal to 10. In which case, it's blank right now because we don't have enough data to have been favorited that much. But you can put any numbers in there you wanted. I believe I saw a question starting. Do you have a question?
I was going to ask if you could use greater than or equal to.
Yep.
Inside of it.
Wow, I was typing that right when your hand went up. Nice. Any questions about having? Because that's pretty much the new thing I've showed you just now. Remember, it's just a where that occurs after group bys.
Derek, we have a question.
Okay.
Are you going to cover where exists?
That's actually nowhere on my list.
Okay.
Like even in the future.
Okay.
Do we want to? I will cover that when I talk about later today when I talk about control flow.
Okay.
Because I'll put that in an if.
Okay.
That's what I'm going to do. That's a good time for it is if. But I'm not to control the flow just yet. Any other questions from them? Cool. All right. Update and delete. All right, we're going to shift gears a little bit. Let me close out some of these screens.
How did you get multiple results like shown at the bottom?
What was the question?
How did you get multiple like results shown at the bottom?
Like this?
Yeah.
So there's really no limit. You can just type a bunch of select statements in a row, and you'll just get lots of different record sets.
Okay. I
And-
didn't know if it just replaced like the one we had previously.
Now,
It's just from those 3 queries up there, yeah.
yeah, the fact that this is basically 3 independent queries. I've stacked them tight because I don't have a lot of vertical space for people who are watching this. Oops. And white space doesn't really matter for the computer's point of view, but it's just 3 different selects. And you saw me do that some yesterday. I had 2 selects together often, and it produces multiple record sets. Depending on what teams you join, some people write their apps so that they use a lot of record sets. I'm in that camp. If I can get a lot of database work done in one database hit, I will pull back many record sets. And we'll talk in a week, and you might even be talking in other products. It's actually not hard in code to advance to the next record set. So you can actually read the rows out of this one, go to the next record set, read them, and there's no effective limit that you would care about as far as how many times you could do that. Hitting a database requires a lot of what we call I/O, input-output. It's a very low performance event. It's very bad. So very often, if I can compact a lot into a single database hit, I will, and pull back multiple record sets to keep the performance high. Opening database connections and getting permissions set up and all that, even before your query executes, is a very heavyweight event, much more than people estimate. And so I will sometimes write code that pulls back many record sets. And my stuff runs a lot faster than people who don't do that. I'm very happy to report. Cool, so we're going to shift gears a little bit. We've talked a lot about one-to-manys and many-to-manys. I want to touch, we've already talked about running multiple statements, which we just did a little bit. I want to talk a little bit about something I showed yesterday but didn't focus too much on. Let me make up something on the spot here. What I want to show is we've done selects a lot. We've selected a lot of data, and often when we select data, we pull back multiple records. Whenever you typed insert, you pretty much did one record at a time, although we did learn that there was a technique for putting in multiple records. But usually insert into, you put in one row. We've done some updates. We had an exercise yesterday where we updated one row at a time, where we marked a to-do item complete. And at least as far as I showed you deleting one record. But I just want to point out that you can do sets. The same way you can select a lot of data, you can do a lot of updating and deleting, and you can pretty much do anything in an update delete that you'd want to do with a select. So I want to just touch on that real quick. It's a small sort of cul-de-sac sort of discussion, but I want to show that it's possible, just so it won't spook you when you see it, because it's written a little bit weird sometimes. So let's pick Smith. Yeah, I'll do customer. Okay. Let me get customers on the screen. And let's say I wanted to clear the email addresses for everybody whose name starts with the letter A or B. All right, I don't want to use a loop. I don't want to have multiple update statements. I just want to clear the email, and I want to do it all in one fell swoop. Here's the technique I suggest. First off, always start with a select statement and get your database and get your data set right that you want to operate on. So I originally said everybody whose name starts with A or B. So we've got all customers. We've got to get Charlie out of there by selecting the Allison and Bobs of the world. So how do we limit a record set? Where? So we'll do where c.firstname Did I think I showed like yesterday once, didn't I?
Yep.
Okay. So I did show like yesterday. I'll just repeat. It's just a text, a sort of evaluation, and the % is a wild card, meaning it doesn't matter what comes after that. You can put them anywhere. You can say it has an A anywhere in the middle, but I'm not going to show you that. We're saying starts with A, and the casing is not important in SQL by default. It can become important, so that might vary from company to company you work for, but by default it doesn't. So if we do this, we get halfway there. We get Alice, but we don't. What do we do about Bob? We need to say also people whose name might start with B. So I can say or first name like B. And yes, I am copying and pasting, so I get to be a little bit faster than you probably are. And there we go. So I'm able to select a nice set of data based on some criteria. So I've selected all the customers whose first name begins with A or their first name begins with B. So I've got all the A's and the B's. If you look at our record set, we're right on the money. Okay? What I can do now, and I might have accidentally done it in front of you yesterday, but I have it on my list to talk about it right now. I can go up here to the select and say update C, that's the alias for customer table, and I can do the action I want to do. Set email address equal to empty. And what I really want you to focus on is you can do what we call, some people call this an update from. I've heard it actually called an update join, even though the word join's not on the screen. A set-based update, whatever you want to call it. I just want to make an emphasis here. It's just a select statement with a different verb. You can do very complex froms and joins, and you can do all sorts of crazy normal, I shouldn't say crazy normal, all of the complex normal query writing you would do with a select statement, and you can come in and make it an update all of a sudden. So I'm going to press F5. I'll see 2 rows affected, and I'm going to use my other tab here to review what our customer table now looks like. And then we get exactly what we wanted. We have Alice and Bob's emails having been blanked out, just because we felt like doing that to them, and Charlie remains untouched.
Can we go back to the query?
Yeah, I'll go back to the query now that I've showed the data. I'll leave that on there a moment. Mostly what I'm emphasizing is that I started with a select star, and then at the very last moment I changed it into an update. That's a technique, so it's more of a tip than anything. If you need to do set-based updates, you do not need to call that in a loop or have multiple different update statements with multiple different where clauses. You can do a lot. I mean, remember, it's a set-based language. Everything you're doing here is in sets. And this language is designed to work over large quantities of things. There's a lot of techniques, and this is one of them for changing a lot of data in one database hit all at once. Questions on that? Go ahead.
I'm seeing 2 rows affected, so how can you show those 2 rows affected? Go back to
So I did go to this tab, and I'll rerun it just to prove. You can see our customer table, which always had 3 in it. The email addresses were successfully blanked out. And you can see Charlie was not touched. His name begins with C. So he is good. He is good to go. So we're back to the update. There's even something more destructive we can do. We can do the same thing with delete. So it's going to, remember, what the query engine's going to do is still going to do the from. It's going to find everybody whose first name starts with A or starts with B, and then it's going to execute whatever I set up here. It's going to delete from that table. I'll remove the white space. I don't have to, but I'm going to. Oop. Oh, he's got phone numbers. Yeah, so this would have worked. This is great, though. This is a good lesson, actually. Yeah. The foreign keys are being enforced upon me as a developer. So I'm trying to delete customers who have child data attached to them. We can't have orphan children. We don't allow that. So phone numbers, and although it's not saying it right now, it would. Even if I cleaned with the phone number table, these customers have favorites as well. So this would actually not work. It won't allow me to do this. I would have to remove all the phone numbers for Alice and Bob first, and then I would have to remove all of the favorites for Alice and Bob. And in fact, now that we've seen the red message, that's what I'm going to do. There is a feature of SQL that some people turn on called cascading deletes, which, as they suggest, will force these deletes down. That's not turned on by default, and I am not a big fan, although some teams are. Do be ready for that. The reason it defaults to off is how dangerous it is. There are some, if you think about it, you might have like an admin record who's like the sort of the godlike login, maybe the owner of the company who owns the product that wrote the software. And if that person's likely to have connections to all data in the database. If you turn on cascading deletes for all those foreign keys, you can accidentally delete the admin and it will remove all data in the database and destroy everything. So generally cascading deletes are frowned upon. I'm getting some nods from Harper, so I'm guessing Sightsource is mostly on the same page. Yeah. Very much on the same page, I can tell by his expression. That makes me happy. But do be ready for that. You might go to a company where they've turned that on. My recommendation is to tell them to turn it off as a first step.
Essentially, the reason why you're getting that message is because you've got a parent table, child table. Those child tables can't, they're pointing with the ID back to the parent table. And if this disappears, they have an invalid pointer. It's like, a phone number might be pointing to customer ID 1. If that 1 goes away, now it's pointing to nothingness, and it can't do that. A foreign key means you have referential integrity in the database, which means if this reference goes away, this one has to go away first. That's what referential integrity means, and it protects your data. It means that your data is not going to get in some weird state where you've got a key to like nothingness.
Yep. And so for Winston-Salem, I'm just going to repeat, Harper just gave a great explanation about the fact that for favorites and phone numbers, they both have a foreign key to customer ID. They're not allowed to point to nothing. Notice they're not null. They have values in them. We have data in them. So that's why these foreign keys don't allow these deletes of the parent data, because the children would have a number that points to nothingness. They would have the number 3 in them, and it points to nothing. And this is a good feature. You're going to want to sort of fall in love with this because it prevented me from screwing up the data right now. I mean, I would have messed it up, but it gave me the red message, which actually leads wonderfully into something I was going to talk about soon anyway. So I'm actually glad that happened. That was wonderful. So if we want that to happen, what do we got to do? We have to clear out the child data first. And I'm just going to do this in the quick and easy way. This won't be the way you always do it on the job, but I'm just looking at the clock, so I'm going to do a quicker solution. I can actually just get rid of all the data, which is the cheat I'm going to do right now. I'm just going to delete all phone numbers. I'm going to delete all favorites. You won't probably do this in the real world, but I'm just doing it the quick and dirty way. I'm going to completely destroy all phone numbers and all favorites, but what that will mean is that there will no longer be any child customer IDs that are undeletable. And these are 3 different deletes. They will occur in 3 different queries, just like when I do a select, I get 3 record sets back, as we were talking about a moment ago. These will be 3 deletes. They'll occur in the order I've typed them. And if all goes well, if I haven't forgotten anything, I probably have. To-do items? To-do items as well. Let me nuke all to-do items. We're really clearing out this database. This is uncommon, but I'm going to do this the sloppy way just for time's sake. This should run, but we're going to find out. Excellent. We deleted 4 phone numbers, we deleted 3 favorites, deleted 2 to-do items, and then finally deleted 2 customers. If we go back to our original data set here, we will find we're down to 1 customer. We do still have products, right, because we didn't delete products. We didn't even try, so that was fine. But you'll notice at the bottom the favorites are empty, and although I'm not showing it on the screen, the phone number table and the to-do items table are completely empty now. They still exist with their columns, but they're empty. There's no rows in them. Which is a great segue into my next point. I've done 4 different deletes here. And that's allowed. You can do as many statements as you want in a query, in a single script. There's no problem there. Let me look at my notes real quick. Delete for product. Yeah. So you can do things in mass in SQL. But it's possible. You could imagine a world where something like to-do item had child data. And I'm not going to mimic this in front of you. I'm just going to talk to you about it. It could have had child data. in which case this delete would have failed for a similar reason. I couldn't have deleted that child data. What that means, though, is that these first two deletes would have successfully run and completed, and then this failed. And that would not be too terrible in the scenario I put together here, but I want you to think about situations that would occur where you're trying to update lots of data in multiple tables, maybe update records here, create some records here, all as one unit of work. But what if there's a mistake or a bug in the system or there's corrupt data and half of the statements run and the other half don't? This could put your system in a state of, I would call corrupted data, where because something only halfway completed, it's neither not done or fully done. It's like in a quantum state where it's halfway done and now it's potentially broken in a way that's not recoverable by usage by the users. I won't describe too many details, but I've been in situations where the dominoes that fell down, figuratively speaking, were very tough to get right again. So what can we do to solve this? Well, there's many ways to solve it, but this is a T-SQL discussion. So I want to introduce a new keyword, a new set of them. And that's the word. You know it's a special word because when I type it, it's blue. You don't necessarily have to follow along. You can if you want. I'm just showing you the keyword. So I'm going to introduce how we use this. You can set up what we generally call transaction blocks. And let me get more. There we go. I used Control-R there to make the results disappear if you ever want to get that off the screen. Now we have this. And this is kind of special, and this is really important. Most database technologies have some way to do transactions. They're almost always called transactions. Sometimes they're called locks. But they're a way to say in your script that this whole set of work is a single unit of work, and we really want it to complete all by itself, or we want it to completely not happen. And we won't talk about how SQL gets this done. It's really magical. It does a lot of cool things. But it basically can execute these things in like a sandbox and sort of construct what the database will look like when it would be done. And you can get all the way to the end. And if it gets to the end successfully and it reaches your commit word, it will actually commit that to the real data. And it will do this in a way that is safe, locked out from other users touching it, and other technical details. I am not going to talk a lot about transactions. I've decided just to introduce the concept. We're not going to really do any exercises based on transactions because it actually gets kind of confusing. It's actually harder to learn. I just want you to know that they're there, what the words mean and why they exist, and what problems they solve. And the problem they solve is if I have two or more statements, meaning like this is a statement. That's one statement, that's two statements, that's three, and this whole thing is a fourth one. If I need all of those things to either completely work without error or none of them occur, I need all or nothing, I need a pure execution of this code, I can wrap these things in transactions and that will happen. So the three things I want you to be aware of, keywords, begin transaction, obviously opens up a block. You can see I've tabbed it in. That's not required, but for readability, it's very common to use tabs to sort of say here's a block. You've seen that in JavaScript, right? You've seen that in an if block, we might open the curly bracket and tab inward. That's just for readability. Computer doesn't care, but human eyes care. So I've tabbed those in just to make them look good. So there's begin transaction. Commit means we've reached the end of the statements. If you can execute them all successfully, Mr. SQL Server, please save them permanently for everybody. All right? And the last one, I'm just going to type it. I'm not going to actually build this correctly. I just want to show you that it exists. At any point, you can call rollback transaction, and that is a way, and we're going to talk in a moment about why you would do that. I'm going to get to that in a few minutes. That's a way to say, oh my goodness, something's gone wrong, so just roll them all back. So it's a way for you, even in the code, to say, maybe I've gotten 3 out of 4 steps done, but never mind, roll them all back. And it will do exactly that. Because it's actually working in a sandbox, rolling back is an easy process. It actually just throws away the sandbox and doesn't change the actual data. And if you think about it, it's doing a lot of cool things under the hood that we don't need to learn, really, or spend too much time on, but it's really cool how it has the real data in the data tables, and it begins to lock some of those records and say it's going to be in a transaction, and other users who are executing queries, like other customers, can't contaminate your transaction. They get their own. It has this cool isolation set of features, which really make it a powerful system. Once again, I compared this at the beginning yesterday with like Excel spreadsheets and stuff like that. The real power of a database is, yes, it's columns and rows, just like a spreadsheet, but it's got these enormously advanced features which make it able to be run concurrently with thousands of active users at any given second, and safely isolate very large units of work from each other, and it's all handled for us. Question?
Can you name that transaction? So like timestamp it, be like, okay, so we did this like 3 weeks ago, and then roll back transaction, whatever the timestamp was?
So the question is, can we name transactions? My answer is, I don't know if you can give them proper names, but the example that you gave, 3 weeks is a long time. I would consider a transaction slow performing if it starts to get in the multi-second range. That's my personal opinion.
It's a wrapper around a
single event. It's a single event that happens to need multiple statements. So there's really 3 weeks would be abhorrent. I would say something's wrong with that software for sure. Now this is multi-second, which in a database world, if you think about Twitter, how many tweets go out in a second? It's actually a rather huge number. Now Twitter's not stored on SQL Server, but pretend it was. It's really about if a tweet occurs and you need to save the tweet and maybe save some other aggregate data, like that person's profile needs to be updated with something like the quantity. You kind of want those to be maybe done atomically. You would need a transaction for that. That transaction actually lives for less than 1 second. If all goes well, they're very short.
So what you do is you just back it up before you commit a transaction. If we're going to do something.
Yeah, if you need to do something over 3 weeks, you're talking about higher level stuff that's way out of scope for us.
You would do like a transaction ID in your table, and sort of like your code would know how to roll back sort of those changes you made. But you would do it. That wouldn't be a database transaction. That would be like an application level thing.
Yeah. Okay.
Yeah. And for Winston-Salem, questions are being asked about large, long-running transactional events in a system that could span days or weeks. That's not what this is for. This is for something that's still probably sub-second or a handful of seconds at maximum. And it's only really valuable if you have multiple statements. If you have one statement, it never needs a transaction. All single statements in T-SQL are already independent transactions, so to speak. It's when you have to span multiple verbs here. It's like select, update, delete, insert. If you needed them all to occur on multiple tables as a single unit of work, you can use the transaction. But you're still aiming for something that runs in less than a second. Question?
This is kind of unrelated, but like when a company has a data breach, is it because they get access to like their SQL code or something? Or is it like when they hack into it or something?
Oh, I love this question. So the question is about data breaches that companies experience, and it can be any of a number of things. The majority of the time, it's actually not a cool answer. Usually it's something really dumb, like they left their laptop in a car and it got stolen, and it's got all the passwords on it. That's usually what happens. If you've watched a lot of hacker movies, I do because I'm a geek. I've seen all those movies. That's not what it's like. It doesn't project on your screen. You're not doing this. There's not cool disco in the back. Whatever's happening. It's usually not that. It's usually something much more simple. To your more direct question, is it because they get access to the SQL code? I would say no. The code itself is usually not impressive and doesn't, like this code isn't going to, hopefully would never contain a password or something like that. But it would be correct to say if they got access to the actual data. So if they actually went to echo here, tasks, if a hacker got access to a network, went to backup and took that BAK file, put it on a thumb drive and walked out with it, that's a gigantic data breach.
So
but usually it's not that impressive. It's usually something dumber.
What's an SQL injector? Because I was reading about this data breach on a website had, and they said it was due to an SQL injector.
Injection, yeah.
Close. So it's SQL injection. That's a very particular thing that I'll get into more when we talk about C#. That'll be the great time to talk about that. But the long and short is when all of these scripts that we're typing here are plain text, as I showed you in a text file. When we go to write some app code, which you'll see next week, and I'll probably show you even the week after that, you're going to see that these exact same scripts can be put into something like C# and executed. Well, I've been hard coding everything. Like when I say customer ID equals 1, obviously you don't put that in an application because I don't know what the customer ID is at design time. That's going to be a parameter. And SQL injection is a very common. It's still so sad how many decades have passed.
It's a little bit.
It's still too common.
Too much, yeah.
After so many decades of SQL injection, and all SQL injection is where you allow a string, you're assembling that string in some programming language like C#, and all the attacker does is they know T-SQL, and they put in semicolons and other special characters to start new statements, so they can customize delete commands. So literally, the worst case scenario
So imagine I'm
is a
logging
URL.
in.
Go ahead and talk. I'm going to type.
Like if I were logging in to Facebook, right, and they said, what's your last name? And instead of Tro, I said select star from users table, right? And then like instead of running that, I could put a semicolon, which is like a start a new line. And as they said, select, check my ID, it would also run that select, because you can do multiple statements of what's all the other users in the database, right? So it may pop up on my screen, everybody in the database. That's what a SQL injection is called. And basically from not sanitizing user input, right? Like taking user input and SQL concatenating the string and making a dynamic query and not checking whether there's something dangerous that got put in there. Most ORMs, most frameworks for accessing databases will sanitize that stuff for you. So it's the people that are like concatenating strings and generating their own queries that get into trouble with this.
Yeah. So I'm going to show you just a lame, contrived example. If I went to Google and I was using the site as a hacker, just using it like a normal person, but I'm an evil actor, a malicious actor, if you look at the URL, that URL is potentially open to SQL injection. You can see I have Google. I just used Google. And I did did the question mark for param. I did a query string parameter, param equals 1. And I might happen to be able to guess that that's my user ID. Well, I could change that URL if Google was terrible, and they're not. Let's pretend that they were terrible. And I changed it to this. I might take a guess that I'm 1. So I'll put in a string as the parameter 1. I'll use a semicolon which in SQL would be start a new statement, and then I type delete space users. Taking a total guess at the users table name, but it's a pretty common name for users. Maybe I might make it singular like Ali. I might try a couple of them. But I could then hit enter here, and if they had a SQL injection problem, when it goes to assemble the parameter for my user ID of 1, it would have the 1 in there, but it would have a T-SQL valid delete command, and it would do just what I did here and nuke all of the users, or it would at least try to. That's a SQL injection attack. It's our responsibility as developers not to make that possible. There are plenty of tools that preclude it, which is why it's ridiculous to me when I see a SQL injection attack work, because we've known about it for decades. It's the same attack with the same technique, same table names every time. But it's still common enough, and we have to talk about it often. When I do code reviews and I see them use what I'll be showing in a couple weeks of something called ADO.NET in C#, that's the tool set for talking to T-SQL, it leaps off the screen now. I know exactly how to identify those. You just look at it and you go, you're screwing up right there, and we fix it. But we'll talk about that in a couple weeks. It's a good question, though. All right, we've got about 10 minutes till 12, so let me make sure I get to a couple other things here regarding transactions. All right. So I've actually removed data to show you that. That's all I'm going to talk about transactions. I just want you to know they're there. They are a first-class topic in and of themselves. They could be a long discussion. I've decided not to talk about them in detail. I just want you to know that they're there and why they're there, and you can research that on your own time. So I'm actually going to reuse that script we had, and I'm going to bring our favorites data back real quick. I want to bring our favorites data back. So if you are following along, I'm going to bring back some of the data. I'm going to open that query, that thing I put in Slack. I'm going to bring the favorites back in. I'll have to bring the 2 customers in as well. I'm going to insert Bob and Alice right back in. All right, I can't do that.
You had identity insert on if you go to the top.
No.
Script.
This will actually take me a few minutes. I'm thinking maybe with 7 minutes to go, we do lunch. During the lunchtime, I'm going to get my database back in a process ready for the next thing.
Yeah, break for lunch. Yeah.
You think so? Okay, so let's break for lunch. During that lunch, I'm going to fix my database up a little bit. I might even put up a new script set for the data, and then we'll resume where we're left off.
Tell them we'll regroup at 1 or start the stream at 1.
We'll regroup at 1 o'clock. 1 o'clock we'll do the stream. Yep. Thank you. And I should stop the stream? Yes. Going offline.